e-commerce player. And last but not least is the growth of new e-commerce players. We are familiar with like Tokopedia, Shopee, Lazada. The second driver is really the globalization of trades and investment, and that ASEAN is further integrating into global economy, especially in terms of the digital economy. So from this diagram, you can see the share of ASEAN in the world import and exports. Both has been rising since 1967 to between 6 to 7%, both import and export. So it is obvious that the share of ASEAN's global trade has been rising, and also foreign direct investment flows into ASEAN has been rising also. The third driver is the improved infrastructure, both soft infrastructure and hard infrastructure. There is definitely a high demand for infrastructure spending, and infrastructure spending is highly correlated to GDP growth. And we are also witnessing a rapid urbanization in various ASEAN countries. And when we have rapid urbanization, the demand for commerce, especially e-commerce, will definitely increase. So this is an overview of the logistic ecosystem an overview of the logistic ecosystem. So you can see that mainly we have like fulfillment centers to transportation, and typically it might even involve cross-border. And you can see that in terms of trends, we can see that in terms of fulfillment, we have like direct from warehouse to fulfillment. We have growing demand from tier 2, tier 3 cities, and also growing in-house fulfillment. And both in terms of freight and last mile delivery, there are various options. Really depends on the particular country. And in terms of cross-border, like I alluded to, the booming e-commerce, and also increasing adoption of various e-payment options. And the various value levels are there. I shan't go into details. But the logistic industry still faces quite a number of problems. The first is really payment, because like every day, close to 140 billion are tied up in payment disputes in the industry. And the average settlement time of an invoice takes up to 42 days. The second problem is the processing and administrative costs. For example, as high as 20% of overall transportation costs are due to paper transactions. The third challenge is shipping integrity. For example, like about 9% of all shipments are related to sensitive pharmaceutical products. And this requires the products are being shipped in certain temperature range. The fourth thing is scalability. Current infrastructure are unlikely to keep up with the growth because many players are using dated systems and heavy reliance on paper-based processes. Last but not least is about efficiency. The industry is struggling to match demand and supply because the demand increased significantly. However, the efficiency level is not there, resulting in a lot of trucks are traveling either empty or partial empty. So what is the kind of blockchain solution that is suitable for the logistic industry? Various components of blockchain technology such as smart contracts, and by combining with other technologies such as route optimization, predictive alerts, and AI-based forward and reverse logistics, and many other things, it could optimize the entire supply chain operation. But before I talk about blockchain in logistics, right, perhaps it's good to understand a little bit about the history of blockchain, starting from Bitcoin, which is really the first application of blockchain technology. If you look at the evolution of money, right, initially the representations of money were physical, from barter trade, right, we go to livestock, commodity, rare shells, gold-backed money. These physical forms of money allows for P2P transfer of value. However, they are inconvenient to be transferred over long distance. So there is this scalability problem. As money becomes increasingly digital, from plastic to digital money, but it creates new problem because when things are digital, it has the problem of double spend, because when it's digital, it's very easy for you to duplicate a copy of that digital thing. So what the industry did to overcome this trust problem is to introduce the concepts of trusted intermediaries like the banks. The banks are acting as the trusted intermediary to move things of value, especially across borders. Okay, for example, in this case, right, you require a sender bank and a recipient bank to handle the transfer of money while ensuring that the same money, digital money, won't be duplicated. But there is one problem with this. The thing is that when you introduce a middleman, first of all, they introduce fees. The second problem is that the processes lengthen, especially in cross-border scenario. For example, in terms of remittance, you will have to cross different time zones of processing and settlement. So this results in longer processing time. So what happened was that in 2009, Bitcoin was introduced to be a peer-to-peer system. So what it does is to replace the middleman, replacing middleman by computer codes and running in the distributed way 24/7 and in a network that there is low or no trust. The premise is that as long as the majority of the computer nodes that is powering the blockchain network, they are honest and properly incentivized, the network will be secure and resilient against failures. So these are some of the properties of blockchain. First is distributed. What it means is that all the processing, all the set of ledger or database is distributed across all the computer nodes. Everyone is holding an exact copy. What it brings in is resiliency, because there won't be any single point of failure, unlike centralized system like the banks. So you can have half of or even majority of the nodes down and the whole network will still be functioning. The other property of, especially for public blockchain, is pseudonymity. What it means is that your identity is partially concealed, because you are only represented by what we call as blockchain address, your wallet address, which is just a string of characters. It is pseudonymous because there are ways to link you, to associate your wallet address to your identity. That's why it's called pseudonymous. The other property, it is timestamp. Basically, all the transactions are timestamped so that you know that this transaction happened at this particular time. And because there is a consensus algorithm running that make sure that the transaction does not duplicate. And in this instance, I say that it is trustless because I shared that actually the entire blockchain network runs on top of internet. And on internet, it's actually, you can't trust anyone, but you use algorithm to make sure that there is trust. The other property is immutability. So basically what it means is that any transaction that already settled, right, can't be changed again. Next is transparency. Basically, in a public blockchain like Bitcoin, all the transactions are transparent, as in like you will know which is the sender address, recipient address, and the amount being sent. Last but not least is programmable. So basically, you can actually add in complex logic into the system so that you can introduce some kind of business logic, such as if then else and the for loop. So this is typically what we call as permissionless blockchain. However, if we were to implement this kind of blockchain in logistic, right, we will need a few improvements. Typically, this is what we call as a permission blockchain. So you can see that the red color fonts are the things that has to be are in a permission blockchain that has been improved over permissionless blockchain in order for it to run in business as use case. For example, all the participants are identified because when you are running, for example, in a logistic blockchain, right, you want to know who you are dealing with. So identification is definitely important. The other thing is that the consensus needs to be a trusted consensus. And a permissionless blockchain like Bitcoin, they use trustless consensus. So all the computers run a kind of algorithm called proof of work. So basically, they will perform some work to solve a mathematical puzzle because everyone don't trust everyone. But the downside of this kind of trustless consensus is that it's very slow. For example, Bitcoin can only process 7 transactions per second compared to up to 20,000 transactions per second by the Visa network. So for permission blockchain, typically they will run trusted consensus. Basically, you will select some of the trusted parties, trusted nodes to run the validation and verification of all the transactions, such as a bank or insurance company. And the last thing is that running in the business blockchain, right, the transactions cannot be transparent. You need to have confidential information that only the relevant participants get to know. It can't be transparent to everyone. So that's the main difference between the permissionless and the permission blockchain. That's why most of the business use cases of blockchain are running on permissioned blockchain. So this is how a blockchain will work. It will start with your intention. The typical intention is that, let's say you want to send A want to send money to B. So a transaction will first be created, and then that transaction will be broadcasted to the entire network. And this is where the validation happens. All the computer nodes, through the broadcasting, they will get a copy of the transaction. They will actually put all these transactions into a block, and each of the transactions they will verify that first is it an authorized transaction from the sender, whether the sender got enough money to send, and a few other things they will verify before they pack all these transactions into a block. Next, this block will then, the miner will then compete to solve a mathematical puzzle. That's now I refer to as a proof of work, in order to win the right to add the block into other earlier blocks of transactions. And in return, if he's the first one to solve the puzzle, right, he will get a block reward and the transaction fees associated with each transaction. And lastly, the whole thing completes when he solves the puzzle. He broadcasts to the rest of the network. The rest of the miners will actually validate that he actually solved the puzzle. All the transactions are valid. Then they will approve this block. Then this is when the transaction is finalized and executed, and the money moves from B to A. Perhaps it's good to understand a little bit about the history of blockchain. Well, I talk about Bitcoin introduced in 2009, right? There are other alternative coins called things like Ripple, Litecoin, that are an improved version of Bitcoin, targeting at payments. But in 2015, something significant happened. Ethereum introduced the concept of smart contracts. So basically, smart contract is the allows you to program your coins in the blockchain in order to perform some complex logic. Then in 2017, some of you might have heard of this term called initial coin offering. This is when a lot of innovation happened that they write on the smart contract platform of Ethereum and came out with some unique application. For example, this token called Filecoin, built on top of Ethereum initially, allows people to share their underutilized hard disk space on the internet, and in return they will earn a Filecoin, which they can sell it for some money. Then in 2018, there is a trend in terms of stable coins and central bank digital currency. So especially because of Facebook, they announced that they want to introduce a stable coin called Facebook Libra, recently rebranded as Facebook Diam. That causes a lot of government to accelerate their experimentation on the central bank digital currency. Last but not least, since second half of last year until now, more innovation happens in the blockchain space. Now we have this thing called decentralized finance and non-fungible tokens. So just now I mentioned a lot about smart contract. So basically, smart contract is actually something that was introduced in 2015 after the introduction of Ethereum. But it is a concept that has been proposed by this guy called Nick Szabo in 1994. Who is an American computer scientist who invented a virtual currency called Bitcoin in 1998. Okay, so basically, smart contract is a self-executing contract with the terms of the agreement between the buyer and the seller being directly written as code. The code and the agreements contained there resides across all the computer nodes in the blockchain network, and the code will control the execution, and the transactions are trackable and immutable. So basically, with smart contract, right, it allows trusted transactions and agreement to be carried out among anonymous parties without the need for any central authority or legal system. So for example, in this case, a supply chain contract and its terms, right, can be written as code into a blockchain. And then this contract will be distributed to all the nodes running on the blockchain network. As the contracted parties start performing the contractual obligation, the contract, which is now implemented as a computer code, will actually self-execute itself when the various conditions are met. So, how are smart contracts being applied in real life in logistics? I think one of the important areas is in the area of letters of credit, which is typically used in the trade industry is a form of financing option for the importer and exporter. Smart contract can provide an efficient solution for all the parties involved because the transparency of the blockchain allows all the stakeholders, whether is it the exporters, importers, and the financial institution, they can view and track and digitally transfer letters of credit as required. This drastically reduces the time required to process a letter of credit. Next is payment triggers. So basically, in many of these supply chain sensors, or what we call Internet of Things, right, they will be planted in the various locations that can automatically notify the smart contracts. For example, when a container has reached a predefined location agreed by the parties, and then they can trigger the payment. The smart contract will receive the information from the container, verifies it, and then release the payment from the escrow account to the seller. The third use case is on the inventory or distribution management by using both smart contracts and GPS location sensors. Each party in the supply chain can see what goods they have and where, whether this manufacturer is seeing what stocks he has and where they are located. and seeing how many client collections they have to complete, or a buyer knowing where is in his warehouse and when he needs to order more. So by combining sensors and smart contract, a lot of this reordering can be automated. In terms of like product tracing for consumers, for example, for consignments, right, they can have their own tracking number and the ability to trace it throughout the supply chain from the manufacturer to the consignee. Then the consumer can check if the products they are buying have been ethically sourced or are counterfeit products. So this is particularly useful in the pharmaceutical industry. Next is the real-time tracking through supply chain. Supply chain information can be readily available to all the stakeholders. This will help to cut down on like port costs, as timing will be better, and the customer's expectation can be managed with early warnings of unforeseen events which could cause a delay. Last thing is the monitoring of temperature sensitive cargo, again with sensors attached to food products or inside the containers. The sensors can constantly monitor the conditions in real time and ensure that they are kept as per the agreed contractual parameters. So this is a comparison of like using a conventional record keeping versus a blockchain version. For example, if a retailer places a product with the supplier, the supplier will acknowledge the receipt of the order. Okay, then the supplier requests the loan from the bank to finance. The bank will provide the financing to the supplier. When the bank provides the financing, the retailer has no idea of this financing at all. So the retailer is the blind party here. The supplier will invoice and ship the merchandise to the retailer. And then in this case, the bank has no idea that the product has been shipped to the retailer. Then the retailer pays the supplier for the merchandise. Again, the bank has no visibility of this. Ultimately, the supplier will repay the bank, and then the bank will close the bank record. And in this case, the retailer is the blind party. Ultimately, if the retailer returns any unsold or damaged merchandise to the supplier and invoice for it, the supplier will pay the invoice. Okay, but in the blockchain version, all these transactions from step 1 to 6, right, are added to a blockchain, and this information can be made available to all the stakeholders. So you can see that the blockchain is actually an append-only kind of ledger or database. As transactions happen, all the transaction information are updated into the blockchain system, and everyone, all the stakeholders in the whole value chain are kept updated of all the information. So this is the biggest advantage of blockchain. Basically, everyone have access to the single source of truth because no one is using a siloed database. So next, I want to go through some 3 examples of how
the regulations in the pharmaceutical industry are changing rapidly to improve drug security. The Drug Supply Chain Security Act was passed in the U.S. in 2013 and requires companies to comply with track and trace regulations. The law has requirements stretching over a 10-year period to increase tracking and security features, including unique identifiers on each unit sold. By 2023, an electronic interoperable system will be required to pass the serial number information between trading partners. And the United States are not alone. Regulations in EU, Asia, and South America have been put in place requiring tracking and authentication. Currently, the pharmaceutical industry in the U.S. uses a patchwork central database approach, which makes large-scale interoperability nearly impossible. Point-to-point integrations are costly, cumbersome, and leaves the risk of diversion, counterfeit, and the trust gap between siloed systems. Blockchain can solve this. The pharmaceutical supply chain is now looking to leverage the blockchain through initiatives like the Meta Ledger project to meet, track, and trace regulation and more. The MetaLedger project has created a permissioned blockchain network for the pharmaceutical industry based on open standards and specifications. It wraps a trust envelope around the supply chain end to end, eliminating counterfeits from entering the system. Every transfer of a product is securely verified as having authenticity and provenance prior to the transfer taking place, which actually eliminates the need to do verifications at all, as every item in the supply chains has proper provenance, or it cannot move forward. Some of the largest names in pharma are involved with 15 nodes being deployed. If you are a service provider, you can run a node, plug in, and earn revenue from selling services. If you are a manufacturer or wholesaler, you can participate in upgrading the U.S. pharma supply chain and driving new ROI in the supply chain part of the business. Join us in the regulation.
So just now is a case of like using blockchain to ensure traceability of drug supply. The next example is on shipping.
Global trade functions much as it has since the introduction of the shipping container in 1956. Manual, paper-based processes are still common, and information about the status of goods is locked away in organizational silos. Today, 90% of goods in global trade are carried by the shipping industry, with the supply chain slowed by the complexity and sheer volume of point-to-point communication across a loosely coupled web of land transportation providers, freight forwarders, customs brokers, governments, ports, and ocean carriers. IBM and Maersk are addressing this problem with a distributed, permission platform accessible by the supply chain ecosystem designed to exchange event data and handle document workflows. Maersk and IBM are employing blockchain technology to create a global, tamper-proof system for digitizing trade workflow and tracking shipments end-to-end, eliminating frictions, including costly point-to-point communications. The collaboration will launch with the potential ability to track millions of container journeys per year and integrate with customs authorities on selected trade lanes. In a recent test by Maersk, shipping a single container of flowers from Kenya to the port of Rotterdam resulted in a stack of nearly 200 communications. Using this example, we will examine how blockchain has been implemented to create trust and security in the digitized document workflow and improve the efficiency of global supply chains. Here we can see each distinct entity involved in the transaction: the growers, export authorities, ports, customs, and importers. Shipping from the port of Mombasa requires signatures from 3 different agencies approving the export and 6 documents that describe the origin, chemical treatment, quality of the produce, and customs duties. Firstly, using a PC or mobile device, the Kenyan farm submits a packing list that becomes visible to all participants. This action initiates a smart contract that enforces an export approval workflow between the 3 agencies. As each agency signs, the status is updated for all to see. Simultaneously, information about the inspection of the flowers, the sealing of the refrigerated container, the pickup by the trucker, and the approval from customs is communicated to the port of Mombasa, allowing them to prepare for the container. All actions relating to the documents and the physical goods are captured and shared: which documents were submitted, when and by whom, where the flowers are and who is in possession of them, and the next steps in their journey. Flowers are perishable, so it's crucial that there are no delays or missteps. Blockchain provides secure data exchange and a tamper-proof repository for these documents and shipping events. This system could significantly reduce delays and fraud, saving billions of dollars annually, and according to the WTO, reducing barriers within the global.
Okay, the last example is basically one that is related for food safety. So basically, by using blockchain, you can provide proof of quality and sustainability, and also allows very targeted and quick product recalls if you found some food that is not correct, and also allows you to provide be compliant to all the import regulation. Due to the time constraint, I shan't go through the video. But the next, I want to dive deeper in a particular blockchain implementation. So this is the case of a blockchain implementation for a vineyard. So basically, you can see that before I start, right, the other important thing is that typically when we implement blockchain, right, it is very possible that that blockchain could also be interacting with other blockchains, such as a banking blockchain for the financing, insurance blockchain for all the risk management related transactions, and a transportation blockchain for the distribution. So in this case, it's a typical case from farm to table for wine, from the growing all the way to the consumer. So basically, the very first contract will embed, for example, all the sales agreement between the grower of the grapes with the wholesaler, whether is it in terms of pricing, quantity, quality, temperature, and time. All these are all encoded into the blockchain system. And then the second thing, all the related information like farming, harvest, and compliance records. For example, like the variety of the grapes, the compliance on the pesticides used, and also data related to growing such as soil, weather, fertilization, irrigation. Next, as the grapes are being sent to the vineyard, during the receiving, the inspection has to be done. All this information are recorded, and then the other things like delivery, scheduling, quality inspection, proof of delivery. And then if the delivery is okay, we can then trigger payment to the grower. At this point, the winemaking process starts, and all the related sample data are again sent over to the blockchain. Again, this is the area that I want to highlight. Typically, a blockchain will need to interoperate or integrate it with your, for example, your enterprise resource system or even your CRM in order to collect and store important information, both that is not available on the blockchain system itself. And then at this point, bottom level kind of traceability needs to be implemented as the wine are being watered. So this is where blockchain will provide the entire transparency of this supply chain, from the origin of the grape to where is it produced. This allows one to verify the authenticity, and also this will allow efficient tracing back and tracing forward in case there is a need to record the wine. And then this is the second last step is really about the distribution. I mean, to the retail. This is where blockchain can be used to track the delivery schedules, and if there are any changes, what are the various location timestamps, temperature, proof of delivery, what are the inventory levels. And once we can prove proof is delivered right, payment can be initiated. Last but not least, as the consumer start consuming the wine, they can do a few things. One of the important things, for example, they can provide immediate feedback, and this information is also stored into the blockchain, so that everyone along the entire value chain can start looking at all the feedback from the data. So this is where big data analytics are very useful. So the entire end-to-end blockchain system for this wine, right, provides this kind of benefits such as efficiency, because you can integrate the processes, which allows you to optimize and automate. You receive you enjoy cost reduction, because both in terms of reductions in labor and human error. You have security and trust, because all the data and the transactions are immutable. More importantly, you have entire end-to-end visibility of the entire value chain. And then the last part is really the business intelligence that you can gather by aggregating and analyzing the data that is being collected from the farm all the way to where the consumer enjoy the wine. So this is my second last slide. So basically, for FTech, right, we have come up with this concept of Trace 8. Basically, is to provide end-to-end visibility of supply chain for crisis-related kind of aids. So you can see Basically, this is just a conceptual diagram of how it works. Basically, we created an API layer that will interface with blockchain, and the various components in the supply chain can then integrate to the API, and ultimately all the intelligence can be displayed in the dashboard. So this is my conclusion. So we can see that by using blockchain in urban logistics, we can ensure authenticity, that we can also ensure that the sourcing of the various goods and products is done according to our terms and conditions. This will result in faster and leaner logistics in global trade, and also increasing traceability and transparency for everyone involved. Ultimately, by automating all the commercial processes in logistics with smart contract, this can result in significant cost reduction. So that's all for my presentation. Happy to take in any Q&A.
Thank you, Mr. Chia Hock Lai. Do we have any questions from the audience, please? Miss Adelina Kamau has a question. Please.
Thank you very much for the interesting presentation, and I'm kind of like attracted to the idea that it will be able to promote transparency and accountability with the beneficiaries and create a space basically for some kind of a feedback mechanism. But the last slide only shows that it can be for urban logistic. Do you think that this is also feasible for humanitarian logistic, and what will be the modification or the differences? Thanks.
Yeah, so we have a member that, for example, they provide solution to provide meshing network in remote areas to provide internet connectivity when there's no availability of internet connection, because they are able to connect to, for example, satellite for data connectivity. And because it uses the meshing network, it allows just one connection to satellite. It enables the entire area to have internet connection. Then this allows the whole network to work even in remote areas, not just in urban areas. So such solutions are already readily available in the market.
Okay. Alternatively, will it be possible, for example, to link it up with local government, so then the feedback is sent through the local government, right? And by doing so, it also encourages further collaboration.
Yeah. So basically, when we use the permission blockchain, all these business rules and logic can be customized. So for example, in your case, you want the feedback to go to a local government, that can be programmed. It's flexible.
Thank you.
Yeah, thanks.
Mr. Chia, we have another question from a Mr. Tanapon, I think. He said, who will be the intermediary holding the smart contract? So
in this case, we are more likely to be using a permission blockchain. So it's up to the party who is designing the blockchain system to decide who will be the validating nodes. So usually you will use people you trust to hold it. For example, could be the local government, could be one of the bank, could be one with the NGO. Basically, there will be a few trusted party that will be holding the smart contract. For a few reasons. These are the trusted parties, so that because they are trusted, right, they don't have to go through a proof of work consensus algorithm. So the transactions can be a few thousand transactions per second. And second thing, these are the trusted parties, so you trust them that they will not do anything malicious to the transactions. Yeah. So it won't be controlled by a single party. So that even if let's say the computer node in let's say the local government goes down, right, the entire network will still be functioning. So to increase the resiliency of the entire network, it is advisable to have more nodes participating in the blockchain.
Okay, thank you. We have another question from Mr. Thomas Fernandez. Mr. Thomas, can I invite you to clarify your question, please?
I think you have to unmute. Mr. Thomas, I think you have to unmute.
Yeah, okay. I tried a moment ago, I couldn't, but now I can. Okay, so when I have these blockchains, I'm thinking about the IBM blockchain, the trade lands. This is not really from origin of the raw material until the final consumer. What we have in humanitarian logistics is that the donor wants to know where do his goods really end up, in which village, and we don't want to know whether anything gets lost on the way, because that is something that does happen. So now I need to trace every single box, because they're being distributed. How do you do that? Do you put a QR code on every box and then it must be scanned in the village where it arrives? How do you guarantee? The problem here is the interface between the real world and the virtual world. How do you know it's really there?
Okay, so whether you are labeling at box level, pallet level, or individual item level depends on your particular use case. For example, the one I talked about on the wine, they are doing it at each wine bottle level because the wine are premium products, so it's worth the cost of doing it. But if you are tracing the things of a lower value, probably you want to trace at the box level. So throughout the whole process, the stakeholders will then need to scan it. Then, of course, the other question is that how do we ensure that they are doing it correctly? So a blockchain can't solve all this problem because it's still garbage in, garbage out. So what is needed is a regular audit process to ensure that, for example, you do spot check, sample check, that these processes are being adhered to. Yeah, blockchain is still garbage in, garbage out in terms of this. Then we have some use cases that they put in the tamper-proof tag inside the product, so that if it's open, right, the whole thing will be the whole thing will be, the data already being tampered with and will be notified within the network. So there are various ways to handle it. It really depends from use case to use case. Thanks.
Thank you. We have one more question. We have several more actually. There is this gentleman, Mr. Ahmad Banuri. Can you clarify your question, please? I couldn't quite get it, and I don't want to misinterpret what you want to know. Okay, but I will read it out anyway. He's not responding. He says, how to handle immutability aspect in blockchain that it can be disturbing. Mr. Chao, are you able to make sense of it?
No, but okay, I do a best guess. For example, he could be referring to, let's say, personal information that are stored in blockchain, and since you can't change, right, that might be a privacy risk. So basically, there are various ways to handle that. Sometimes the actual information you don't store in the blockchain, you use some cryptography. For example, you just store the hashes of the information that are private there. Or you have, especially in the permission blockchain, you can have private channels So basically, only those parties relevant to the transaction, they can view the transaction. It's transparent to other participants. The other way is what we call the use of zero knowledge proof. So basically, you don't have to, you can prove, for example, that this item exists without giving up the details of all this. So basically, by employing various cryptographic techniques on the blockchain, right, the privacy level can be enhanced. So I presume this is related to the other question on how smart contract can help confidential contract for business. Typically, in permission blockchain, you can indicate that certain transactions are confidential. Only those relevant parties are privy to the transactions.
Thank you.
Maybe I want to clarify, Mr. Rahul, that I mean, it's disturbing in here is when we put some information in blockchain, that's will be added the new block, isn't it, in the block of chain, and that will be take another data. I mean, it's the size of the data. And if we make wrong information that block cannot be deleted from blockchain, then so I mean, it's how to make sure that the information that we put in the blockchain is the correct information. Because so if not the correct, so the block will be, the size of the block will be higher and higher. That's I mean.
Yeah, so just now I mentioned is garbage in, garbage out. Unfortunately, if you put in the incorrect information, you will leave that. But what you can do is, because it functions like how accounting works is append only. You cannot if you make a wrong debit or credit, you cannot go and reverse it. What you do is you add in a new accounting entry to offset the incorrect information. So it works the same for blockchain. If you identify there is an incorrect information, right, you add in a new information to replace that. The incorrect one will still be there because that will be your audit trail. And then that is actually important to many people. But you have a new entry to indicate this is the latest entry. And all this information anyway are easily retrievable from the blockchain system. I hope that addressed your question. I see another question from Thomas Fernandez. Can permission the blockchain be hacked? Definitely. But just now I mentioned that in permission blockchain, what is important are the validators, right? Let's say you can select four government agencies to be the validators. So if two out of four of them are hacked, right, then the system could be compromised. So it's better that you have more. If you want to increase the security level, you have more validators in the system. That will definitely increase the resiliency of the entire system.
Thank you. I'm afraid we have to move on.
Thanks.
For the sake of time, thank you very much for your questions. Please feel free to send your questions in the chat. And if Mr. Chakola, if your time allows you, perhaps you can address it in the chat. And I would like to invite our next speaker. Mr. Kelvin Goh is the director from the Global IoT Division, SAS, and he will be sharing with us what are digital dashboards. Kelvin, please.
Thanks, Yong. Can I just quickly check with you if you might be able to see the screen that I'm sharing?
Yes, I can. Thank you.
Okay, awesome. Thanks. Then I know I'm ready to go. So thank you everyone for your time. Distinguished guests, also fellow speakers, been extremely educational, learned a lot. Okay, so from Mr. Chia's very, I would say, state-of-the-art complex conversation, I'll bring us now to something a bit more fundamental, okay, on the concept of digital dashboards. Okay, and also, right, okay, I'm also going to brief in some of the new techniques or some of the newer techniques that I come across when it comes to working on visualizations and also different types of analytics that could be used and put into a digital dashboard. So that will be my presentation, okay, for today. All right. So very quickly, to share a little bit about the organization that I work for, that I work with. Okay, SAS is a company that has been around for a long time. We have been for 44, 45 years now in the space of business analytics. Okay, so I will not bore you all with too much details other than it's a very old company that's been around for a long, long time, working in the same space of business intelligence and data analytics, right? Okay, all this while. Okay. So a bit more about myself. Okay, so I myself am responsible for business development work in the area of logistics, IoT, and also global trade subjects. Okay, so 20 years of experience covering a whole gamut of different organizations, with organizations such as Defense Science of Singapore, Federal Express as a supply chain consultant. Okay, also with Infocom Media Development, along the way did some e-freight related kind of projects. Okay, before I went into really hardcore IT space, having spent time with IBM, SAP, and now with SAS. Okay, I also work with the Singapore Armed Forces as a logistic officer. So the topics that we are covering today is very close to heart because it is not just from my professional work, but also in my other work where I get as a NS officer. Okay, I also have to deal with logistic and operational matters. Okay, yeah, so that's a bit about myself and how my affiliation with logistics is useful in some conversations today. Now, I'm going to jump straight into the proper pertaining to dashboarding, okay, and also what it means, right? Okay, so let me start by talking about the current state of affair, right? Okay, is I think some of the other speakers also alluded to. There's a lot of data, okay, and a lot of data actually sits in static and sometimes even in Excel spreadsheets. Okay, so it is not unusual to have users, right, being overwhelmed by data and not insight. Okay, at the same time, right, it's very common to see the IT team within any organizations to focus on helping to produce reports. Okay, and at the same time, right, struggling with it because the data actually cuts across different silos of the organization. So what all this means, right, is firstly, it's extremely inefficient, but I think there are implications that are actually worse. Okay, so first and foremost, right, is a lot of time we actually see wrong decisions or suboptimal decisions being made because of the inadequacy or the non-consistency of data. Okay, so that itself, right, is a big no-no. And when that happens, right, the longer run in terms of implication-wise is there's a mistrust organizationally for the information that is in place or not in place. Okay, so that's it, right? I guess today's context is how do we actually overcome some of this in the context of both urban logistics and also in the context of if we can apply some of those considerations into humanitarian logistics. So let me put it this way, right? When we are working on visualization, dashboard, BI kind of projects, there's often, right, a long list of intention or ask from the parties that we're working with. So some of the desirable traits, right, of a project or for a good dashboard, right, is the users expect it to be accurate, expect it to be easy to use, expect it to be content-rich, it's current, information is current. As much as possible, it should be tailored to the need of the people who needs to interpret the data or read the reports. At the same time, right, preferably there's some level of intelligence built into the capabilities. Better still, if the users, right, can implement or exercise a level of self-service, and the most important thing, right, it must be interactive. So which brings to the first point, right, what really is the difference between a dashboard versus a report? I would say in two simple ways, right, to look at it is first and foremost, report is static, and tends to look at what had happened. Whereas a dashboard has the potential to stay interactive, stay current, and even go on to push it to become real time. Okay, so I'll address it from some of my illustrations later in terms of what are some of these principles and philosophies. The last thing to note, right, is it's very typical that reports don't tend to be tailored to individuals. And henceforth, right, when you look at the different stakeholders, each of the parties here will have their own requirements. And therefore, right, you have got concepts like, for example, management dashboard versus operational dashboard, so on and so forth. Okay, so all this, right, as much as possible, if there's a single solution that it allows you to really make it easy to consume in terms of the data and also in terms of the insights, then that will be a good dashboard, so to speak. But later we'll see, right, dashboards has also evolved. I'm going to use examples of the pandemic recently to talk about how some of this dashboard actually come alive and become so important, getting a lot of attention. And from there, which country, which government, which agencies is pushing it one step further to be able to use the dashboards itself to help them make very important decisions. So that is where I'm going headed on next. Now, this is a very simple use case, right? I shouldn't say it's simple. In fact, right, this is a use case to really illustrate how do you create situational awareness when in the situation of crisis. Now, of course, I have to state in point and state in clear, right? Dashboarding is used everywhere in every context. So I think earlier we have seen speakers from like Kelly and also Clarence representing E2Open and Oracle respectively. They've given us already some snapshots and ideas, right, as to how dashboards could be used, and at the same time, how is it being utilized, right, across different facets of the logistics supply chain sector. So this is where I will state by, first and foremost, right, in order to work on this particular use case, the first thing we did was to really look into all the data types that we have. What kind of analysis do we want to perform? And what kind of insights do we want to provide to the eventual end users? So these are very logical steps, just for every project to go through this. Now, when I distribute my slides later here, this link, right, is going to bring us to a COVID tracking dashboard that SAS has put together on public domain, which everybody is free to access. Let me see if this link can work, right? Okay, great. Yon, can I just double check if you can see the screen transferring over to 2019 coronavirus dashboard?
I cannot.
You cannot. Okay, so I think what I have to do is to share again, this time now to the web page. Okay, thanks for helping me, Yon.
Okay, now I see it.
Okay, great. All right, so to the audience, right, this is a public domain web page. It's something that my organization has put together since COVID really broke out in late 2019 and then early 2000. So I'm not going to talk in details, right, as to what you can see and what is the underlying techniques here, right? But I'm going to just give a quick illustration as to typical dashboard, what they look like. So you can see that in this case here, what we're looking at is a summary statistics, right, of a lot of the cases that has happened around the world. And then you can usually get interactive with it, right, because you can click on stuff. Will present you with new information. If you run your mouse over, right, it's very often that you can get another level of details. So like for example, in this case here, what we're looking at right now, right, is really the spread of the disease, right, around the world. Going by different category and classification. So if I continue to scroll on, right, you can see that now we're using different kind of table forms to be able to look at newly confirmed cases, right, over the last 7 days. So keep in mind, right, these are real time, because what we are looking at, right, is literally information, right, that's happening over the last few days, as you could see, until the 20th of June, because it's based on US time. And if I just kind of zoom in, zoom out, right, we will be able to see the rest of the more detailed information. Here we can see some information, right, that goes by country. So if I go on to a different place now, let's look at this on the global cases. So the system is loading. All right. So what we have here, right, if you all can see the tab here, we are looking at the global status. We also have got other things like, for example, the location analysis, the trend analysis, the spread over time, so on and so forth. Let's just take a quick look, right, at this one called spread over time. What do we see? Now, in this case here, what is happening in some of this screens here is literally showing us the timeline in terms of how the disease actually spread very rapidly around the world. So as we can see, right, as we move along the time bar here, right, it's going to depict more and more serious as the disease spreads around the world. You can see some of the colors are changing now as the timeline, as the time bar, right, is moving. So these are some examples, right, of what dashboards is capable of in terms of showing information to us, and then from there we harvest insights so that we can make certain decisions. So I'm going to stop showing you all this particular dashboard now, and I'll go back to the presentation. So now I'm back to my presentation mode, right? Okay. So this is the cycle that we went through. Essentially, is to gather the kind of data that is available. Okay, and then we go through the analytics by designing, right, okay, what we exactly want to see, and then at the same time, right, okay, create insight so that people who need to use the information can actually make a decision. But the information earlier, okay, at the country levels and so forth, it will be more useful if you zoom down into it, go more granular, and from there on, do other kind of analysis. So let me show you all what else can be done. Now, when we look at this screen here, okay, the map should be very familiar, okay, because this map, right, okay, is one of the ASEAN country, the Philippines. Okay. So when COVID actually first took place, we were working on we're trying to understand the geographical spread, okay, of the virus itself. And from there, by understanding the direction of the spread itself, monitoring the number of cases and frequency, we're trying to preempt logistically in terms of how to prepare the forward stocking locations, okay, and also the hospitals, right, okay, so that it has got enough equipment and also the right kind of skill sets to prepare for whatever that is coming. So when you think about this, right, okay, this is already going beyond just dashboarding and situational awareness. You're actually using information that we have put together to start to anticipate what is going to happen. So there's an element of prediction that's going to come along. So I'm going to show a couple more of such screenshots. Right? Now this particular case here, right, okay, is actually we also have the information of the telco service providers. So we're able to actually understand the mobility and behavior pattern. Okay. So what we have here, right, okay, in the screen here is literally understanding both the mobility and also the spread velocity. With that, right, okay, what we're trying to do is when you go along the major township and also city itself, we're starting to anticipate, right, okay, where will be the next area that's going to have the biggest problem. Okay, and with that, right, okay, the intention of, again, right, okay, trying to put in place the necessary measures in order to be able to preempt and therefore respond very promptly to the situation that's happening on the ground. Okay, so the techniques here, right, okay, involve a few things, right? Okay, there's a couple of GSI layers that you can see here, as in map layers that you see here. But it's more than that, because if we understand the underlying technique here, right, okay, there's a difference between just going straight line as how the crow flies, right, okay, this having to work on the physical road network that is actually available on the ground, okay, also all the connection nodes and so forth, okay. So these are the kind of information, right, okay, that usually can play a very important role when you really try to make sense of what's going on. Okay, when I discussed this with Dr. Bob D'Souza, right, okay, one of my favorite concepts in humanitarian logistics is all the traditional supply chain and logistic models may not work. Okay, you're hear it correctly, right? Okay, may not work. That's because traditional logistics, right, it doesn't account for all the disruption brought about by whatever that's happening on the ground. So in the case of a flood, earthquake, so on and so forth itself, it will not be able to use the same concept center of gravity to design your entire operation network. And henceforth, the currency of the data and knowing what you're trying to analyze, right, it becomes even more important because you systematically design and address what's the problem statement first before you really go in and see how you put the system together. Okay, then go on, right? So this is one more further explanation, right, okay, going into the network matrix part, okay, where we're actually looking into really overlaying it from a physical infrastructure angle, okay, so that we understand everything, right, okay, from road to bridges to literally, right, okay, whatever else that can pick up at that point of time, so that we're able to really create some of the network matrices that is necessary in order to start anticipating the spread of the virus, okay, and therefore, right, okay, the logistic operation. Okay. So all said, right, okay, in the end, it is all about the people, right? Okay, the entire logistics operation is meant to provide relief for the people. Okay, so another view of the dashboard itself, right, okay, needless to say, will be what is happening to the populace. But with that, right, okay, this is where we also will go into the specifics in terms of the demography, the segmentation, where are the clusters, so on and so forth, so that we can use it for a few purposes, right? Of course, you can try to do dispersion. You can use it, right, okay, for other kind of, say, a greater focus of allocation, right, okay, for all the resources. Now, all said, in the end, right, okay, the dashboard itself is a form of, it's a way for us to consume information. But what is more important, right, okay, it goes back to the original point about design. Which brings me to now some of the more you can say sharing a spec, right? Okay, in terms of modern digital dashboards. Okay, what are some of the real enabling pieces, right, that allow us to do those things that we spoke about earlier, right? So it's very easy to put things into graph and tables, okay, but it is much more tougher, right, okay, to answer to what I shared earlier about data accuracy, about lineages, about explainability, so on and so forth. So I'm going to just keep this very simple, right, okay, to address what are some of the enabling pieces to get modern dashboards, right, okay, to be really better and also serve the purpose. Okay, so first and foremost, right, okay, I think all dashboards has to be interactive. Okay, so example of interactive, right, okay, will be good layout, okay, easy to create. At the same time, right, okay, it has got a lot of functionality that allows you to do things like filters, drill down, so on and so forth. It should also enable you to share the information and then collaborate, right, okay, with parties. Okay. So what this means, right, okay, is getting the data ready so that you can leverage on interactive reports and interaction, right, okay, becomes very important. Let's go on, right, okay, and talk about what else are suitable and good techniques. Okay. The next thing about dashboards, right, okay, is increasingly a lot of mini dashboards, right, okay, has got this component called visual exploration. Okay. By visual exploration, it means you are using different underlying capabilities of software and technology stack to do things like, for example, discover relationships, okay, understand outliers. Now, outliers, right, okay, when we do our basic degree in the past, outliers is like you can just ignore, okay. But in our world, right, okay, outliers are dangerous, okay. So you want to actually look into outliers and not ignore them. Okay, likewise, right, okay, the proliferation of clusters usually has also meaning. Okay, so what are the work of typical data scientists, citizen data scientists, right, okay, is they are using visual exploration to really understand all the kind of relationships, okay, so that you can also use some of the techniques there to be able to understand what is actually causing those observations. So let me just walk us through, right, very quickly in terms of some of the illustration here, what actually it means. Now this one, if you follow my cursor here on the top left, this is some kind of what-if analysis. Okay, so in the logistics space, right, it's very often that we look at, for example, the number of ASN that's being dropped into a warehouse, okay, and how many SKUs, right, okay, do you need to pick pack, okay, and then from there, right, okay, you need to palletize it, right, okay, before it's moved out for the shipment. Situation like this, right, okay, is a day-to-day thing, okay, but if you're able to use some of the what-if calculation to understand how many pallet jets or how many trucks, right, okay, to prepare, right, okay, this will become forward-looking. So one element of visual exploration, right, is literally using such techniques to really understand what's to come, and therefore again you plan ahead. Now, if you follow my cursor on the bottom one here, this is it's a kind of a decision tree diagram. Okay, if you get more complex, right, okay, it's also in the form of sometimes what we call a Sankey diagram. Okay, but the idea here, right, okay, is to understand it from a path and weight angle. Okay. So what it's trying to say here, right, okay, is if let's say an item is actually picked up at one location and then actually delivered at the end location, if you're trying to understand it from an capacity impact angle, or from the fact whether there is capacity to carry those goods directly to and fro, or maybe you're trying to find the underlying reason why is it that there's always delays, right, okay, this is one technique that could be used. Okay. Then we look at this one here, right, okay, in the middle. This is essentially, right, okay, a form of text analysis. Okay, so if you are collecting reports, right, okay, as to why delays are happening, or you are trying to look into all your logistic transaction information, right, okay, and try to see all the big words, for example, custom delay, or for example, certain HS code, right, okay, is problematic. Okay, this is another technique that could be used, right, okay, when you look into the text analysis part to really understand what is causing certain behaviors. I think I have to speed up a little bit, so let me go further, go faster a little bit. Now I'm going to introduce another new concept, right, okay, that is prevalent now in the industry, increasingly more solutions, right, okay, starting to introduce this. It's the idea of visual exploration, but with the concept of augmented analytics. Now, big words, right, okay, what it means is this. Now, a lot of time, right, okay, if you're trying to understand inventory, for example, in a warehouse, there's no reason why a data scientist or a business analyst has to build it from scratch. The intention, right, okay, is to, as much as possible, given the fact that inventory, how you display it on the dashboard is essentially the same. There are companies, right, okay, that is working on the idea of auto charting. You need to say, right, okay, you throw the information in, it automatically populates some of the BI or some of the dashboards so that it starts to tell you information even before you design what information you want. Okay, so in other words, right, okay, the system is interpreting the data on its own, okay, and present it in the kind of templates that is most commonly adopted, okay, by a certain practice, a certain business practice. Like in the case of what I just illustrated, maybe it's in the form of inventory accounting, maybe it's in the form, right, okay, of transport. Okay, in terms of how you track the original destination pairing, and then you understand it, right, okay, from delays and all the hops that it makes. Okay, likewise, right, okay, some of the rest of the information, I think these are the same kind of concept here, where it will actually suggest certain visualization that is useful to you. Likewise, right, okay, certain matrices and KPI measurements that is typical. Say, for example, estimated arrival time versus actual arrival time. These are standard. Okay, so from a templated approach, right, okay, this is becoming a new feature, right, okay, that we can find in a lot of the dashboarding capabilities out in the market. Next, I go on, right, okay, to explain something called location analytics. Now, this topic, right, okay, is I think everybody will believe that they have a certain level of experience and they probably know what this is. Okay, it's because when you look at the map itself and you see how we use a GSI layer, a map layer, to depict, say, for example, assets, dispersion, right, here of assets and resources, so on and so forth. We will then use the longitude and the latitude of a map itself, match it, and therefore use it, right, to do all sorts of answer questions. Okay, but the underlying techniques below, right, okay, is a little bit more complicated. Okay, so there are actually concepts like, for example, the travel time analysis, the distance analysis, and also using polygons, right? Okay, polygons is like a way to kind of box into a particular area. Okay, so that you really understand not just the map for the sake of the map itself, but the underlying pieces, right, okay, around there that can make a difference to your measurements or your matrices. Okay, so these are techniques, right, okay, that if you are not in the IT space itself, right, you probably won't be too concerned. But the analyst, right, okay, will really know how to use some of those techniques. Like I said, how the distance is measured as the crow flies, right, in a straight line is not depicting the actual, because when you're moving on the ground, when you're going on one path, right, okay, it's a total different thing altogether. So there's no point, right, assuming that you can travel 50 kilometers per hour, drawing one straight line point to point on the map. What you need, right, okay, is to really account for anything from the contours, the gradients, the speed limit, right, to be able to really materially calculate accurately in terms of what exactly is going to be the time required, so on and so forth. The other thing that I will bring back, right, is a bit of a backward here, is the idea of data preparation, right, it actually has to be done correctly. Okay, most dashboards, right, okay, like I said, the worst is when you don't do this part correctly with inaccurate information, right, okay, people do not trust what is coming out of it. Okay, so data preparation, right, okay, is actually important. Just want to introduce the concept of augmented visualization. There is also a concept of augmented data preparation, whereby systems take in your data and automatically understand it from the macro data level or from the data view level, right, okay, to really understand what kind of data are those. Okay, and from there, right, okay, it actually helps an analyst to prepare the kind of dashboards you want to build later. Okay, so example, right, okay, if a data is actually alphanumeric versus something, right, okay, that is strictly binary, say a male, female, okay, systems, right, will be able to understand those things at the data level, and there's no reason anyone would point to it and say that, oh, this is actually a gender data, henceforth the selection can only be male or female, okay, so on and so forth. Right. The next thing, right, okay, is in all dashboards nowadays, right, okay, it's important to think of the form factor. Okay, so it has to typically, right, okay, work on a few kind of applications. Okay, and you want to make sure, right, okay, it is write one, publish many. By that, right, it means whatever that's been created, ideally, you should be able to get a copy of it, right, okay, on the internet via web. It should run as an application on your desktop. It should also, right, okay, be accessible via your mobile and your handhelds, okay, as a form of a mobile app. Okay, so the concept of write one, publish many, right, okay, is another concept that's very typical in dashboard design nowadays. Okay, then the idea of collaboration applications is because it's no good just having a dashboard that gives you information when you cannot interact and exchange. Okay, so one example, right, okay, is if let's say you need to embed a graph and strip it and immediately send it out via a chat to the rest of your collaborators, right? Now, in this case here, if a feature for collaboration is actually designed with a solution, it makes things a lot simpler. Otherwise, again, it's a broken process. Okay. Lastly, at least for the first part, right, okay, is the concept of governance. Okay. The concept of governance is important is because it will look into a few things, right? Anything from image, organization to management to just now, I think some people spoke about auditability and audit trail. All these are important features, right, to be designed into the concept of modern digital dashboards. So all these are the basic. Okay, these are the basic, and I reiterate, right, okay, that it is something that is not difficult to do. It is already widely available. I'm going to touch on, right, okay, in the next 15 minutes, right, okay, the what else. Okay, so I'm going to introduce a few other ways of doing dashboarding or features in dashboarding, right, okay, that's leveraging on some of those big words that you see here. Okay, the idea of edge analytics, graph techniques, streaming analytics, the ability to do advanced prediction and forecasting, and also a concept that I actually advocate a lot, right, okay, is to understand the time and space converge. Okay, a spatial temporal view, right, okay, is really important. Okay, and lastly, right, okay, in the big circle itself is also how do we leverage on some of the very often talked about artificial intelligence techniques, right? How do they come alive in, again, the concept of dashboarding and visualization? I hope I haven't lost too many people. Just allow me to carry on, yeah. Now, I'm going to start by talking a little bit, right, okay, about the idea of streaming analytics. Now, I think just now Mr. Chia, very quickly, he actually spoke about, in the case of, say, for example, you're tracking a pharmaceutical shipment, or you could also be tracking, say, for example, temperature control shipment. Now, the traditional practice, right, okay, is to use some kind of a temperature logger, okay, and then at the end of the journey itself, you plug it in the computer, okay, and then you look at the trend to see whether there's any temperature excursion. Now, as a logistician myself, right, okay, I can say that that's never good enough, okay, because by the time it gets there, right, okay, the entire shipment could have already been compromised, okay. So the idea of batch, or eventually, right, only at the tail end that you look into the data and then to perform the analysis, right, okay, is never good enough. So one of the common techniques, right, okay, that is very prevalent nowadays, enabled by IoT, is the idea of streaming and then analysis at the same time. Okay, by that, right, okay, if we follow some of the big words here, it's not just about pushing data through, but also applying some kind of decision-making models at the edge, so that you can decide at that point in time, good or no good, yes or no, go or no go, etc., etc. Okay. At the same time, right, okay, this technique, right, okay, is made available by a very corresponding capability called edge compute, which I'll touch on very shortly. Okay, so when we look at this diagram on the left, the idea is this: whether is it real time or no real time, right? Okay, in the past, when you put the data and put it through an analysis environment, the main thing here, right, okay, is it is not making a decision for you at the edge at its real time, at a real time basis. Okay, henceforth, sometimes it's not good enough. Okay, so today, right, okay, if we have got a relief effort going on, it is to be rushed, right, okay, by the golden hour in order to reach a group of, say, casualties, okay, medical supplies, or sometimes water tablets. Okay, you actually need to know where that thing is, right, okay, there and then, to be able to make a responsive reaction. To know it only after you reach, right, because you got a on-spot POD at that location itself, after everything has been done, that's not good enough, right? So if I use this similar concept, right, okay, to explain one step further, the idea of edge analysis, this is because compute, as in the ability to really do the mathematical computation, has become so small in signature nowadays. A lot of IoT devices can actually run decision models right at the furthest edge. So just now we heard a lot of words, right, okay, like for example, demand sensing. Okay, demand sensing, right, is a good example for everything that's picked up from the aisle. Okay, for everything, right, okay, that is taken away, right, okay, from the factory itself. If you are able to demand sense what is going on the ground itself, you are able to design decision-making processes, right, okay, that's closer to the spot. Okay, henceforth, right, okay, you become a more responsive supply chain, a more responsive logistics operation. Okay, so this concept, right, okay, I'm going to use a very simple two graphs, right, okay, two diagrams, two videos to illustrate. Now, on the left, right, okay, is an example of machine performance, right, okay, that's taking place. The scenario here is the raw data is being streamed real time, okay, with visualization. Let's see quickly, right, okay, what happens here. What happens here, right, okay, is information is going to come through, okay, when you can see that with the rapid movement, right, okay, it's actually depicting that data is coming in. But what is it telling you? Actually, it tells us nothing. Okay, it only tells us that data is flowing through real time, okay. Now, on the left, on the right-hand side here, right, okay, is a diagram where we show if you apply an anomaly detection model at the edge itself, you'll be able to see that the data is coming through will show the abnormality. So let's look at it over here. Now in this case here, right, okay, what is happening is the data is still flowing through, but the data that's flowing through is being scored against. Okay, meaning to say, right, okay, based on whatever is the model that you have built, it's usually trying to score, right, okay, to understand how does it compare with the rest of all the peers that is being monitored here. 9 of them, which one, right, okay, is actually performing abnormally. So in this case here, when we apply the anomaly detection model here, it actually flags out, right, okay, which are the one that needs the attention, right, okay, from the technician and the engineers. So this is what we mean by streaming analytics and edge analysis, right, okay, are 3 fundamentally related but different concepts. And once we are able to harness and understand how we can use it, right, okay, it will enhance the next level of capabilities, right, okay, within the dashboard capability that we're trying to build here. Let me go on. The next concept, right, okay, is it's not new, okay, it's the concept of prediction and forecasting. Now, prediction and forecasting, right, okay, has always been something that is important, right, okay, in logistics, supply chain operation. What has changed, right, okay, is beyond time series even. It's the idea of using some AI techniques, right, okay, to look into forecasting. Okay, I won't go into details here. In the future, when we run other workshops, right, okay, we'll go into the next level of details. But the evolution, right, okay, and also involvement of some of the mathematical formula, combining traditional forecasting capability together with something we call deep learning. I think most of you have heard of neural network and deep learning, right? Has created a new layer of capabilities, right, okay, that is can be made available now in the area of prediction and forecasting. So these are pretty advanced techniques, right, okay, that is actually made possible because of deep learning. Okay, over and beyond traditional forecasting and prediction. Next, this one is important, right, okay, and I would like to spend some time to just illustrate this a bit deeper. There's a technique, right, okay, called graph, okay, where it is very useful to look into the network analysis, okay, or the network impact, right, okay, of when you have got a complex network, okay, of data, okay, and you're trying to understand the relationship, the interaction, the lineage, okay, and at the same time, right, okay, is most often used, right, okay, to solve situations where you're trying to identify your weakest link and also, right, to address a lot of the inefficiency that you see. So why is it very useful, right, okay, in logistics supply chain? Is because logistics supply chain by tradition, right, okay, there is a lot of players. It's a very fragmented industry, okay, and it's very difficult sometimes, right, okay, to pinpoint where exactly are the weakest point. Now, I've done enough corrective action review in the past, right, okay, to tell you that a lot of time, right, okay, the number of failure points that account for one single failure, okay, tends to be multiple, right? That means to say there are multiple weaknesses, right? Okay. The worst thing, right, okay, is the same weaknesses will appear again and again and again. Okay, because when you are doing corrective action review, right, you're not really addressing the root cause of the problem. Okay, so sorry, I digress, right? Okay, but the point here is graph technique is very useful to use it for this purpose. Now, if I can zoom in and ask the audience, right, okay, to look in a little deeper. This graph here, right, okay, is actually used for us to do contact tracing. Okay, but the underlying technique, right, okay, was first created to perform investigation, especially into crime, especially into fraud, especially into money laundering kind of projects. But in the humanitarian logistics space, right, okay, this technique was also used, right, okay, for a few other purposes. Firstly, right, okay, is for use to look into network weaknesses. Secondly, right, okay, especially in the case of natural disaster, it was actually used to connect internationally displaced personnel, IDPs, right, okay, when they are just separated from their families, or when two parties, right, okay, that needs to be together is separated. Okay, so the possibility here, right, okay, is very wide. Okay, the main thing here, right, okay, is when you are able to see the resolution and the relationship between entities, you will usually be able to find some kind of relationship that therefore allows you to commence either some kind of investigation or some kind of tracing, right, okay, so that you can get to the bottom of an issue. Okay, so this technique, right, okay, is one of the most important technique that I think the team here could benefit from, because it's one of the technique, right, okay, that we strongly advocate for consideration. Okay, this example in this screenshot here, right, is actually talking about the same technique but being used for contact tracing in project that are done in Brazil. Okay, so the idea here, right, okay, is when two parties, right, okay, are in fact interacting, okay, how do you then understand it from the risk angle itself, therefore go and look at contact trace the party, right, when they are when they're actually exposed, right, as a potential patient, right, for corona. So a lot of countries have got similar concept here, but I'm not sure how many agencies, right, actually use a system to do this in a more effective manner. So let me just go on nonetheless. Now I'm going to show this particular next topic here, right? Is the idea of time and space converge. Now, you might remember earlier, right? I already showed a similar screenshot here. This is actually the spread of the coronavirus at the initial phase, right, in the Philippines. Okay. So what happened here? The point I'm trying to illustrate is this. Very often, especially in the operations that we are in, right? It is not just enough to understand the physical distribution of, say, assets, people, so on and so forth, and put them on the map layer. Okay, it will stay static if that's the case, right? And it's not pretty useful, right? Okay, so this is the that will be the spatial view. Okay, but if you look at the time bar below, right? Okay, when you look at all the timestamps below, we are actually tracking it, right? Okay, from a time angle. Okay, so the time angle, right, here is actually time stamped so that when things does happen itself, you are able to pinpoint the timestamp and then connect it to also the longitude and latitude to exactly where things happen. Okay, so this particular point, right, okay, that I'm trying to advocate here is this: design with the time and space converging, right, okay, as a very important dimensionality. Okay, because a lot of the rest of the components, right, okay, that we're trying to design, say for example, point A to point B in terms of relief effort, and then from there tracking whether you get there, you don't get there. This particular concept, right, will be important. What's even more important is when you design your system right from the beginning to have got this time and space converge, it will become a lot simpler to perform investigation later or retrospectively investigate what had happened. Okay, so some parties mentioned earlier, right, about forward logistics, and then there's always a concept of reverse logistics. Okay, to a certain extent, right, okay, that is what I'm trying to say. Okay, today, right, okay, too much emphasis is always put on just the forward part, but not enough design consideration is put into the reverse part. Okay, which is why, right, okay, this idea of when you put this time and space converge together, you'll be able to perform investigation and also root cause analysis a lot easier when you have got this concept featured early in the conversation. Right. So actually coming to the last part of my sharing. Okay, so if I might summarize, right, okay, earlier I showed 6 bubbles initially to talk about some of the features, capabilities that we should always put into all the dashboards capability or control tower capabilities or situational awareness capabilities. But when combined with some of the rest of the techniques that I was talking about, graph techniques, IoT techniques, streaming capabilities, forecasting capabilities, and also various AI capabilities, for example, in the case of natural language understanding, for example, in the area of computer vision, you create new kind of dashboards or situational awareness capability that is one generation, or I would say it is the most timely type, right, that you can use for future proofing. So I'm just going to use one very simple example to show how newer dashboards, right, tends to look like. Now this example, right, is very, very simple. Okay, it's just one small project that we did, right, for an airport. Okay, I'm trying to illustrate here, right, to over and beyond the usual control tower concept itself. How else do you bring in the AI component to give you that next level of situational awareness? In the end, right, okay, all this is for the purpose of so that you can make decisions better together, right? So this example here, right, is we're looking at an airplane, okay, and then there are dashboards on the left. Let's go to the next slide, right, where you can see the video. Right. So what's happening here, right, is this plane actually got taxied in earlier, okay, and as with all airport operation, right, what it's most concerned about, right, is how fast you can turn around the flight so that the flight itself will be able to turn around quickly and then to park, okay, and then not affect the rest of the parties. Otherwise, right, there will always be a rescheduling calculation that's happening. Now, what's happening definitely, right, is from a commercial camera itself, we are doing a few techniques like, for example, object detection to understand, for example, the number of people that's moving around, understand where is the plane, understand the trolley earlier, right, that is pulling the luggage away, and then you got timestamp. So what actually happens here, right, is literally the concept of dashboards, right, has gone one step further because it's actually incorporating also real-time situational awareness on the ground based on activities so that you can do quick calculation on the spot, right, in order to turn this flight around. Okay, now this is an airport operation context. in the military operation context, right, okay, what will actually happen, right, okay, and how this is often used is, we also have seen how similar examples, right, say for example, we are doing tracking of activities around your area operation, okay, and then you're flying drones, and drones is actually picking up signatures, right, in terms of how vehicles and people are moving. Okay, so the concept here, right, is similar. So I'm not saying one is better than the other. I'm just highlighting that when you put some of the modern neuro techniques, right, okay, to the more conventional concept of dashboarding itself, you create a new layer of capabilities that enables you to do the kind of analysis that you need. In the end, right, okay, whatever we're talking about here, I think the big word that we're going to take away is whatever you do is to enable that real-time collaboration, okay, so that people can make better decisions. Okay. With that, actually, that's the end of my sharing. Okay, and I can take a few questions. I trust if I have the time. Thank you.
Thank you, Kelvin. Thank you very much. Thanks for your sharing. Do we have anyone with a question? Any questions for Mr. Kelvin Goh? Okay, if we do not have any questions from the audience, maybe you take some time to think about it. At this point, let's take a very short break, all right? We are slightly behind schedule, but I think we are doing fine, all right? The time now is about 3:40 p.m. Let's take a 10 minutes break, everyone. And we come back to this room at around 10 minutes to 4. That will be 3:50 p.m. Singapore time. If you do not need a break, feel free to just stay on in this room. Or if any of you has questions for Mr. Kelvin Goh, feel free to raise your hands or post your questions in the chat. Thank you.
Makanya begini. Aku mau bikin chai guys. Habis kok. Udah aku minum. Tahu. Semua yang belum tes ya. Aku besok aja deh. Besok masih WFH. Kok. Saya masih ada loh, Jaya di situ, mau Jaya.
Good afternoon, everyone. Welcome back to the Zoom meeting. I hope you have had your coffee. Next, we will invite two gentlemen to present on digital twins from concept to practice. Okay, we have with us Mr. Stepan Agorov, the product manager from NE Logistics, and Mr. Giuseppe Imperio, manager with the Logistics Institute Asia Pacific and US.
Hello. So shall I start the presentation?
Yes, please.
Okay. Let me demonstrate my screen. Can you see my screen now? Yeah?
Yes, we can.
Yes.
Great. So, hello everybody. My name is Stepan, and I'm the product manager at NE Logistics, supply chain software. And today with me is Giuseppe, manager at National University Singapore. And we're going to talk about digital twins, supply chain digital twins, from concept to practice. And I will be talking about concept, and Giuseppe will be talking about practice. Okay, so a couple words about who I am. I represent the Logic company, global software company. We are a world leader in simulation and optimization software tools, and we have two products. First is Logic simulation modeling software, and the second one, which we are going to talk about, is Logistics supply chain analytics software. And here are some of our clients. There's a lot of clients from around the world, huge companies, including 40% of Fortune 100 companies. So what are we going to talk about today? Supply chain digital twins. And first, we'll begin with some definition of a digital twin and delve a little bit more about into simulation, the product, the technology underneath. Some examples of simulation and say concepts of digital twins and control towers. And then I pass it over to Giuseppe, who will cover his case study. So, what is a digital twin? So, you know, there are numerous definitions to this term, and nobody knows which is right. If we look at Gartner, probably the most respected source of information about technology, they say that a digital twin is a digital representation of a real-world entity or system. And you know, this is quite a broad definition, and it's hard to understand what they mean. Now, if you're just curious and go to Wikipedia, there will be numerous definitions and they'll be all different, but they have all something in common. What is this? So they all mention simulation, sensor updates, again, simulation, dynamics, some kind of real-time data, and understanding, learning, reasoning. And these are the words most often used to describe a digital twin. Simulation, real-time data, dynamic, and so on. So there's something about simulation, certainly, and how we as a simulation technology developer see digital twin and how our customers see it. A digital twin in supply chain is a detailed simulation model of a supply chain, of a logistics network, connected to some real-time data snapshot, using some real-time data from operational systems. And the model provides supply chain dynamics forecast, which allows for understanding, learning, and reasoning. And this is a supply chain digital twin, which actually allows for taking midterm decisions, like simulating a few months of operations, and short-term decisions as well, more for kind of operational problems, low-level problems, which require to simulate a few days or weeks. And what are the problems that you can solve with a digital twin? So there are various problems, and if we take a look at this pyramid, some high abstraction, high level problems with a low level of details are included. In first place, for example, where to locate DCs or factories, where to stock products, supply chain master planning, to some medium level problems such as inventory sourcing policy planning and different other policies such as transportation policies or even risk analysis, to the lowest abstraction level where you model a very detailed thing such as a warehouse inside four walls or a factory inside four walls, and you can see how production planning process inside a factory can influence the whole supply chain. And this is something you can achieve with a digital twin. Now, to understand a little bit what a simulation is important, because simulation, as I said, is the technology underneath. Well, simulation is a computer representation of your real world system. Like, for example, you want to model a supply chain that has a client, a DC or warehouse, a factory, and a supplier, and you set the rules of operation in a software tool. For example, a customer places orders for 300 units per day every 4 days, or no, 4 days a week, okay? And then a DC has some initial inventory, and if this inventory falls below some level, they order a batch or from a factory. If the factory has enough raw materials to start production, if they don't have, they order it from supplier. And if supplier workers are on strike, they will not process the orders. So this is the rules that you model, that you set, and then you have this model and can run a simulation. So this is modeling and this is simulation. You run the model to see the dynamics of it and to see how it performs over time. So, for example, on day 1, customers orders 300 units, day 2, they order 300 units, day 3, day 4, the same. On day 5, the DC runs out of stock and they have to order another replenishment order, from the upstream. And the factory starts production. When the factory on the day 7 falls, raw material stock falls below a certain level, they order from a supplier. And this is how it works. You can see the whole thing in operation in dynamics. And this allows you to gather statistics over time. For example, you can see the inventory level at DC at every given day. And this allows for learning from the dynamics of supply chain and experimenting with what ifs. So dynamic simulation model, you represent how the actual rules of supply chain are structured, like actual supply chain, like inventory policies, sourcing policies, and so on, with randomness, with time, and so on. You are, as a supply chain specialist, conduct the modeling process and get the detailed results with stats like orders per day or inventory at each given day, lead time, and so on and so forth. This is simulation. And let's take a look a bit at the demo. Now, this is a logistics software product, a tool for modeling and analysis and building digital twins. And we can see a simulation model here. So this is a simulation model of some mock global supply chain, just a simple model as an example, with some objects on the map. We can see the structure of it. If we take a look at the structure view, so we have a supplier in China, we have 2 factories in China that supplies DCs in different locations. Some of them are supplied directly, and some through ports, which serve as cross-docks in this model. And then DCs supply customers, and some ports supply customers directly too. So this is all located on the map, and you can inspect how it looks. Take a look at the routes, paths between facilities, and the data is set in the tables. For example, inventory. We have our inventory policies. This is order on demand. for different factories. For DCs, it's min-max policies with certain parameters like reordering points and some initial stocks, bombs, which define how certain products are produced, and we have defined
Stefan,
yeah.
Giuseppe here. Are you attempting to show us a demo in the tool, or because we are just seeing a static screen?
Oh my God.
Yeah. You may need to reshare the screen again with the right window.
Okay, I'm sorry.
Not to worry.
Yeah. Can you see it now?
Yes, now we can see it. Yeah. You may want to take us again from the start, if it's okay.
Yeah. If that's all right.
Sure.
Okay, so what I was showing is this. This is the model, yeah, and we have different sites here. They're located in different places, yeah. And we have a structure view. We can take a look at how supply chain is structured. This is suppliers, factories, DCs, so they're connected between each other, yeah, and these are ports that serve as cross docks in this model, yeah, and then DCs supply customers, all right, and so we can look at the connections between them as well on the map, yeah, all right, so this is the supply chain that we have, and the data is defined in the tables. For example, we have our DCs that have certain policy parameters for inventory, like some certain reordering points and ordering rules with some initial stocks. We also have defined some facility expenses for storage. We have defined some products. We have defined some bombs, how the products are produced, and so on and so forth. So demand is also defined. And we can run the simulation to see how the supply chain behaves over time. Now, let's see. We can see that something is moving, and these purple dots on the map represent shipments, and we see the model animation in the real time. Yeah, and we see that we simulate 1 year of operations, and what's more interesting is that the stats are also changing dynamically. We can observe how they change. For example, this is revenue versus total cost, and we can see how they change over time. Also, profit and loss statement. So we can see how these things dynamically evolve over time, like inventory spend, inventory carrying cost, tariffs in different countries, transportation costs, production costs, and so on and so forth. And also, what's interesting is that we can see available inventory on a chart like this. For example, if we take a DC at Asunción and we want to know how much furniture is stored, this is the line for them, and we can see how much furniture was stored at each given day. So taking a look at this, at such charts, we can understand what capacity the DC should have, for example, because if we see that the storage was not more than 350 units at any given day, then probably our warehouse should not be bigger. So I'll run the model a bit faster so that we complete the simulation. Wait, how do I? Yeah. And we can take a look at another example, which is a risk analysis thing. So we saw that it was quite a simple and deterministic model. But in the real life, we know that supply chains are subject to risks. And who knows it better than people who manage disaster management logistics, yeah? So this is quite obvious that we have random events and they influence how a supply chain behaves. So in this example, we'll see how it works. For example, we have a factory in Vietnam and we have a port which serves as a cross dock, and they supply certain number of DCs and customers in Japan. And we have defined the model, but what we have here in addition to what I already showed to you is random events. For example, we have a certain probability that a rainy season in Vietnam may impede the production and stop factory from producing. So just randomly, let me set it for 50%, yeah? And with the end of rainy season, for sure the production will be restored. We can also see that with certain probabilities, 80 and 90%, there can be increase or decrease in demand. And we also take into account the probability of factory failure of 50%. So it can fail randomly throughout the year, and it will recover for 7 days. So let's run the risk analysis experiment and see how this random events may impact our supply chain. Now, the issue with risk analysis experiment is that we run the simulation for several times, several replications. So we're running this scenario for 30 times, and in certain runs, the random events will occur, in certain runs they will not occur, and there will not be risks. So we understand this way how risks affect the performance of the supply chain. So we run the simulation and we have this best, mean, worst graph. Our target metric to optimize is service level here, and we can see that in the best scenario the service level was always 1, in the mean scenario it was falling due to some disruptions, and in the worst scenario it was even falling down to 0 with no recovery until the end of the simulation, which is not a good thing. So we also have data for events and recovery. So we see that in certain number of events, like in 14 replications, there was no failure, so everything went all right. In 13 runs, there was a disruption, but there was no recovery. So the supply chain wasn't able to recover until the end of the simulation. And in one case, it was able to recover. So this way we can see that probably we need to increase some resilience or robustness for our supply chain, and probably add some alternative suppliers or alternative factories where we can produce goods so that nothing is impeded so seriously. Okay, so getting back to the slides. Can you see the slides now? Yeah.
Yes.
Okay. Have a little more to say about digital twins. So we say I just show you simulation, but for sure this is not the only thing that can be included into a digital twin. It also can leverage optimization and even AI technologies. How can it work here? So simulation is giving you forecasts. It doesn't give you like directions what to do, where to go. For this, you can use optimization. So how does it work? For example, you run the forecast, you run the simulation. On day 1, the forecast is okay. Day 2 is okay again. Day 3 and day 4, an unexpected event happens. Hurricane destroys DC network. So we have to rearrange our supply chain so that it recovers. And we can run an optimization, which can suggest you an adjusted supply chain structure with different DCs selected. And this suggested structure can be fed back into the digital twin, and it can keep forecasting, and this will allow you to restructure your supply chain on the fly. So yeah, for sure, optimization and even AI can be in place of optimization here, can be a part of a digital twin. Now, if we say that a simulation model is a digital twin, this is quite a narrow definition. Usually, simulation model is a part of something bigger to make it a digital twin. Now, what it has to do? What makes a model a digital twin? First, it's a detailed model. It's not just some model. It has to be able to predict the behavior of your supply chain in details and with really preciseness, with high preciseness. It has to use some real-time data snapshot, has to be connected to data from your operational systems, such as ERP systems, like SAP, for example, or supply chain management systems. And it has to be able to provide you with notifications and alerts when something abnormal happens. Like, for example, if the forecast shows you that we'll be running out of stock soon, you'll have to be able to receive these alerts to make changes to the structure, to test some what-if scenarios and make the changes required. Triggers, again, some if-then actions, like if the disruption occurs, run the optimization, just as I showed in the previous slide. Test and action plan, for sure, you have to be able to run what-if scenarios with the digital twin, like change parameters in the model, run it again, see how the changes affect the situation, and connection to the IT infrastructure of the company or the organization. Because in many cases, the digital twin is part of some bigger thing, like a control tower, which I'll show later, which allows you to integrate your model with some real-time data. Now, how usually a digital twin is structured? First, this is the IT infrastructure that I mentioned. The systems that store operational data of the supply chain, like ERP, like SAP, or supply chain management systems, or manufacturing management systems, warehouse management systems. So they all store the current state of the supply chain. Now, if you feed this data into a model built in logistics, you can make a forecast based on the current data. And you can conduct different kinds of experiments, like what-ifs, optimization, risk analysis that I showed you, simulation, and so on. And users and stakeholders can do it. And what is more, in logistics can connect to some business intelligence tools, such as Power BI or Tableau, that are sometimes more convenient to use than built-in visualizations for managers and stakeholders in the organization. So they can host this BI dashboards on their company service and like connect to them through a browser. And yeah, the control tower is a concept that people and clients are asking about more and more. It's a central hub, a central repository for management inside a company. Yeah, it's not only for supply chain, it's for everything. So it has two main modules. First is these dashboards, business intelligence dashboards and visualizations. And second is the data underneath. So it has three pillars. First is the current state of the supply chain. And this is the operational tools that I mentioned that people are using for managing supply chains day to day, such as SAP. Second is the forecasting model, the decision support model. And this is the digital twin. Some model built in logistics connected to this operational systems. So it can be a supply chain digital twin. People can also build manufacturing digital twin, financial digital twin, and so on and so forth. So it's not only limited to supply chains, but we are talking about here supply chains. Yeah, And the third part is the task and case management, is some project management tools maybe, or task management, where stakeholders and managers assign certain actions to some responsible people who take responsibility of the changes required to operate our network, our company. Yeah, and basically this decision support module is where logistics fits in as the tool for, it allows you to integrate your real-time data with a simulation model, forecasting. It enables you to model, design, and analyze your supply chain. And what's unique about logistics is that it leverages two analytics engines. First is dynamic simulation, which uses AnyLogic engine underneath, and AnyLogic is the worldwide leader in simulation. And second is optimization techniques by IBM Simplex, which is also the top solver in the LP world. And the combination of both makes logistics a very flexible tool that allows you to model your supply chain in much details and capture all the special traits of your logistics network. Now on to the case study. I shall pass it over to Giuseppe from the National University of Singapore. And National University of Singapore is, one of the central hubs in the world, I should say, for simulation expertise. It's certainly one of the biggest in Southeast Asia. So Giuseppe will present his projects, his real-life projects. Giuseppe?
All right.
Please, you can continue.
Okay, great. Thank you so much, Stefan. If you'll allow me, I will just share the screen. I will need your help to stop sharing your screen, Stefan.
Yeah. Get it.
Okay, got it. Okay. Okay, can you see my screen in presentation mode?
Yes, yes.
Okay, good. Okay, thank you so much, Stefan, for the presentation and for giving us such a good overview on what this digital twin is about. If you'll allow me, I will spend the next 10 minutes trying to share a little bit an application that we have done a couple of years ago using some of the tools that Stefan has presented. And the reason why actually we want to share a little bit about this particular use case is because the topic of this of today is basically the digital transformation, right? Digital journey in your supply chain management or in your logistics operations. So what actually from the research standpoint, what comes immediately to mind is to really transform whatever you are doing in your real life into a digital world. So digital world means in the world of computer, right? So computer models is what comes to mind immediately. We have heard actually earlier today some of our esteemed colleagues mentioning about the technology stack that is required to actually enable your transformation journey, and that's been a super presentation. What actually I'm going to share with you today is a little bit the heart of the digital transformation, which is basically is the first step of moving from the real world into the world of computer. And then on top of that, all the nice technologies that our colleagues have been talking about. So the use case I will be presenting is about Indonesia. It's a use case in the domain of humanitarian logistics. And it's a use case that we built a couple of years ago. I think everybody is familiar with some of the things I will be sharing in the introductory piece of my presentation. I will just try to run it very quickly in the interest of time. So the rationale of this particular use case that we built was related to the fact that, of course, the frequency of humanitarian crises is exploding. Humanitarian logistics is one of the areas that where we have a greater interest, especially in this part of the world, due to the fact that most of the countries in ASEAN sit on the ring of fire. And humanitarian logistics is a very special application of supply chain management practices, because it's a use case where you do not know really where the demand is going to be triggered, how large the demand is going to be. So it's a very special and unique case of supply chain management, and the supply chain and a use case of great interest because of a lot of variables that come into the system. So in this particular use case, what we have attempted to do is to basically bring resilience in a supply chain in a supply chain case study by designing a network of pre-positioning stockpile. So stockpile pre-positioning, as our humanitarian colleagues that are here on the call today will know, is one of the practices that is currently in place. And in this particular use case, we basically try to give an answer to two main questions. And give me a while, and I will go back to the previous slide. The first question that we had in mind was really trying to understand the capacities and the design of this network. So in the use case of Indonesia, we tried to understand what was the most optimum configuration. So where we should locate our stock. So that was the first question. And the second question that we had in mind was basically trying to understand, in a time of an emergency, in a time of disaster, how this network would perform. So we have basically included what Stefan before has been mentioning in terms of, number one, events, and number two, basically simulating what a possible disaster could mean in terms of demand. The use case that we had was Indonesia. For those who live in this region of the world, they will know only too well how Indonesia is a very unique case for whenever it comes to humanitarian logistics. It's one of the largest countries in the world, definitely the largest in Southeast Asia, has a very large population. Logistically, is one of the most challenging countries in the whole world because it's an archipelago of 17,000 islands. The country is widely exposed to natural disaster of very different kinds, slow onset, sudden onset. There is, at the moment, there are some areas of the country, especially the western part, and Java Island in the main is more developed in terms of infrastructure compared, for instance, to the eastern side of the country. So all that in terms of logistics means challenges. And this is why Indonesia today, and this was one of the report in 2019, the 24% of the national GDP goes in logistics. So when we try to translate these challenges from the humanitarian standpoint, we can try to understand that there is really a pressing challenge to streamline some of the logistics processes. So what we did here at TNUS, we looked at this problem of, again, trying to design a network of prepositioned stockpile to be activated in a time of an emergency. And what we did, I will try to go here very quickly, again in the interest of time, but we basically try to do two main things. We have had a series of interviews and focus group discussion with key stakeholders in Indonesia. This took place back in 2017 to basically get an understanding of where possible locations for the warehouses could be. Then we have used any logistics, and that's what you will see in phase 2, to basically optimize the network. So out of a set of possible facilities, any logistics helps us understand which ones were the optimum sites. And number 3, we have activated the demand and basically we build a simulation model that would simulate what goes on in a time of an emergency. So to that extent, simulation is what helps. Is a very much of a demand focused approach because the whole supply chain is activated according to the requirements of the beneficiaries. So that's where actually we saw any logistics and simulation in particular really helpful for this particular use case. I will just share a little bit of what were the boundaries and objective again of this particular use case. So we were actually our task was to determine which ones were the most optimum locations. And the initial objective was to try to minimize the cost. Why are we trying to minimize the cost? Because we are trying to build a supply chain that is cost effective in the main, but then we test the service level and the resilience of the supply chain to meet the humanitarian objective using simulation. So that's what happens here in the second step. So first we determine which one were the optimum site, and then we test them in terms of basically in terms of resilience and service level to meet, of course, the humanitarian objectives using a real life case, real life data. So what has happened here? We have used the actual data from from the major disasters that struck in Indonesia in between 2004 and 2016. The model had we have considered 186 regencies across Indonesia, and so we have modeled 11 big scale emergencies and 489 small to medium scale disasters, which were mostly floods. And this set of data, we basically feed it inside the system to test how our network would perform. Here, I'm just going to go quickly through some of the outcomes. Of course, for those who are interested, we will be happy to share reports and more information. I'm just a little bit mindful of time. So when actually we are speaking about network optimization, so from the design standpoint, whenever actually we are undertaking the digital transformation journey, we are trying to understand how actually a network should be designed in the first place. So we did a little bit of a design exercise using network optimization and any logistics. So our task was to identify 6 possible warehouses, 1 per main island in Indonesia. So any logistics helped us understand which ones were the most suitable 6 sites out of 9 that were identified through focus group discussion. So leaders and experts from basically a number of stakeholders that are based in Indonesia, they were sharing with us the possible sites. They came down to 9 across the archipelago. Using any logistics, we have selected the most optimum 6 out of these 9, which was our main task. So at this stage, we knew which 6 sites were suitable or potentially suitable. What we have done next, we have built a simulation. So we are feeding the data from actual disasters in terms of impact, and we run the supply chain and see how the supply chain performs. So here I'm just showcasing some of the insights. So the insights were basically in terms of how large the fleet should be, how big our warehouses should be. So more in terms of requirements of the supply chain, right, to serve these particular demand points. This is how the simulation model that we build look like. So we have, this one is basically the flow, which is basically the fulfillment operations. This one is just a snapshot of our computer model. And as soon as a disaster strike, that you will see here basically fulfilling that there is a material flow happening, you will see the performance of the supply chain. So this piece that basically we have done here is not yet a digital twin. As basically Stefan was mentioning in the earlier part of this discussion, a digital twin is way more than a simulation model. What we have built though is just the starting point. So what we have done here, we built a detailed simulation model. If we are able to feed real-time data into the simulation model, that's where actually we are starting to slowly move into a digital twin, and which will become an actual digital twin 100% when we will be able to do demand forecast, for example, or dynamic forecast also in terms of capacities, and we are able to trigger alarms or abnormal situation in, for example, in a set of dashboards that connects with what Kelvin has been sharing before. So what we have done in this particular use case, I just want to highlight it once again, is not a digital twin, it's just a simulation model, which is just the starting point of the digital twin. And again here, this is another way to look at it. In your digital journey, always simulation would be, we envision it to be the starting point. On top of it, you will need the real-time feed. You will need to start doing prediction. That's when you move into digital twin. On top of which you can position a set of dashboards to monitor performances of your supply chain. In this particular piece, we just put down a little bit of some challenges that could be addressed using simulation. For example, addressing some of the points that beforehand at the start of today were shared by Adelina from AHA Center, the point of really much being demand driven, or really much, or how actually the whole material flow can come together with cash-based transfer and new programs on how, for instance, moving a little bit or having different views from a regional, the country level, but really putting at the heart of the digital transformation, the people and the beneficiaries, and just leveraging technology as an enabler. So these are just some set of challenges that we laid. And to this, I come to the end of my presentation. I hope I kept it within the 10 minutes. All right, so if there is questions, I'll be happy to take it.
Yeah, I'm also happy to answer your questions, guys. Please go ahead. Yeah, Thomas says you'll need a myriad of data points to always keep it updated. Yeah, that is true. So it really takes some effort to prepare the data, and possibly data preparation is one of the hardest things, as I know from consultants who build models. It's probably one of the hardest things to create a digital twin, but today this is becoming easier and more possible with big data, because every interaction is collected and tracked in supply chain management systems, and this is possible now. Well, of course, you also need some computational power and run a model on a server. That is true, but this is where the world is moving today, as we see it from the industry. Yeah, automated data collection. So this is some kind of so when data is stored in supply chain management systems, well, they are stored from sometimes even physical locations and physical items, like scanning barcodes in a warehouse, and the inventory levels are updating in the system. And this is how it is fed. Then the data is transformed and is fed in the model. This is how it works. Will blockchain be of advantage? Well, I think I don't see any direct way of introducing blockchain right here. I think there will be more presentations about that. I saw that we have colleagues talking about blockchain usage for supply chain in other talks.
So maybe I will step in there, Stefan. I don't think in the digital twin you would have a role for the blockchain. I think, yes, you're right, we covered it after lunch in the presentation, but that would be more in the execution than in the design and having to plan it. Thank you.
Thank you, Dr. D'Souza. Okay, so
if we have no more questions, thank you very much, Stefan and Giuseppe. Thank you for your presentation. Next, next, we would like to invite Mr. Ryan Yap. Mr. Ryan Yap is the head of growth from the Executive Chairman's Office, the YCH Group. He will be sharing with us on logistics execution, E2E integration without borders. Ryan, if you are ready.
Hi, thank you. Let me just pull up the slide first.
Thank you.
Okay, so I'm just going to address the elephant in the room. What is E2E? I think, at least to me, that means end-to-end. So what I'm going to take you through is an end-to-end journey map, if you will. And to do that, I actually do need to go into the history. So forgive me if you're wondering what does the company introduction have anything to do with what YCH is doing in our supply chain space. But as we go through the presentation, I'm sure you'll be able to draw those links because at least to me, at least to us, our DNA, our history, our culture plays a very large part in how we run our supply chains in end-to-end fashion. So without further ado, I'm going to begin. One more thing is I'm generally pretty informal, so I'm not sure if you all can speak, but if you all want to interrupt me, please feel free to do so, rather than wait until the Q&A. All right. So, rising with the vision, YCH, I think first and foremost, I'd like to introduce that we are a family company. First and foremost, we've been around for about 66 years. We're 10 years older than Singapore itself. And we started out in passenger transportation. I think all family companies have one thing in common, which is very humble beginnings. And we started moving people because this was in the 50s. You didn't have public buses, trains, none of that at the time. In the 70s, YCH faced our first major disruption with the advent of public transport, and we lost 90%, 97% of our revenue overnight. But being a family business, the management refused to release any of their workers. Retrench, zero, no retrenchment, but 3% of your business is left. Right, so that's when our founding chairman, Dr. Robert, took over the reins and said, all right, I have people, I have trucks, I just don't have business. So what do? We need to innovate, we need to change the way we work, but we need to look at it from a different angle. So we moved from passenger transportation into serving cargo transportation. We heeded the clarion call of the Port of Singapore, and we said, like, all right, you want to be an entrepreneur trade hub, you need people, I can move your stuff for you. Well, that was a partial fib, but we need to improve our skills. We retrained, we had to learn how to move cargo instead of having cargo move itself, because that's what passengers do. So that was the 70s, and we were quite fortunate that we did well. I think there's a lot of leading by example happening here, with the chairman himself getting down to the ground, moving the truck, moving the cargo, moving the trucks, and inspiring the people to change. And I think that attitude served us well. It was a need to innovate or we die. I think that was the reality in the 70s. With the arrival of the .com era and the arrival of computers, we actually took the chance to design our own software systems. And that was by chance again. Well, what happened was we had a customer who was doing computers. They went bust, we had computers. So what we did is we took the computers we had and tried to invent our own software system. I think at the time we were the first local supply chain company to develop their own in-house warehouse management systems. And that allowed us to look at things in a holistic fashion, because once you get to the solutions and supply, the actual IT systems and software, that allows us to really plug in and see what do my customers need. And at the time, what was needed was quality software, right, that could allow for many flexible models. And this flexible model, I think some of you might be aware, was vendor managed inventory. It's a supply chain ethos where you actually push the ownership of the inventory to the suppliers instead of the traditional model where the manufacturer buys the stock, processes it, and then out goes to the finished product. This customer was compact, and it's because of our ability to create and develop software that suited this requirement. That's how we started to move and advance into end-to-end supply chain management. This vendor managed inventory, I'll call it VMI, took off with Compact, it took off with Motorola, and now we also began to serve Dell. And today we still serve Dell because obviously Compact is no longer around, and neither is Motorola. So we will still serve Dell for vendor managed inventory, and that is really what brought us to where we are today in what I call end-to-end supply chain management. And our guiding light, our vision has always been to bring all our partners, customers, vendors, whatever, into what we call the logistics superhighway. And this consists of 3 flows. It consists of the physical flow, physical data, what you can see, what you can touch. Information flow, this is what's within your PCs, your AI models and all that, information flow. Financial flow is whatever's inside your wallet and your bank accounts. Hopefully this is the largest flow, right? And bringing all these 3 together and having that as our guiding light, that has been what has allowed us to orchestrate and design solutions that are end-to-end. Because when we look at supply chains, we look at it from these 3 flows. If any of these flows are not tip-top, to us, that's not end-to-end supply chain management. And that's what I mean by culture drives our execution. Okay. Just to show you graphically, right? So when you look at supply chain, there's warehousing, there's a network study, there's business intelligence, there's even energy management. I think what this slide really wants to encapsulate and show that it's, to us, it's not just about warehousing, logistics, trucks, right? It's about the entire value chain behind it, including the sourcing, including human capital, including energy management, and of course sustainability, as what we are looking all at today in this increasingly hot climate. So that's kind of where our heart and our head is at. But just to show you where we are, at YCH, I think we were quite fortunate. We managed to grow into the region. We are specifically focused in Asia Pac. We have about 16 countries, about 100 locations. The idea is to build depth rather than to cover as many countries as possible. I wouldn't be happy if we have only 16 locations in 100 countries, because that's impossible, but that is also not the right focus. The reason why we want deep networks is, again, that logistics superhighway we want to build. We want that connectivity, we want that depth of network, we want that flexibility. You can't do that with a very shallow network profile. And I think that approach has, touched a lot of our customers, because we tend to look at it holistically. If you look at the brands on the board here, these are a lot of them at the top, the S&P 500 companies of the world. And if you notice, what's interesting is that we actually cut across a number of industries rather than focusing on, let's say, electronics or automobiles. That's because I would say we choose to look at it holistically. We choose to only be good in two things, which is supporting manufacturing and supporting fulfillment. And in doing so, you cover the entire supply chain. And that is, I think, what attracts a lot of our customers to work with us, to put that much trust in us. So much so that every year we have about $50 to $60 billion worth of inventory running through our hands, our systems on an annual basis. Bear in mind, this is not my revenue. This is just what I'm on the hook for. This is my liability. I will cover this last bit just to show you where we've come from. So from where we were, a humble passenger transport company, we've moved into this era, which we call the 4.0 era. And to commemorate that, we actually were able to secure a cutting-edge facility, an iconic facility, we call it Supply Chain City, right in the heart of the Jurong Innovation District. And the idea of the Supply Chain City is to build an icon for supply chain sustainability, for supply chain growth, as well as to build an ecosystem to further feed the innovation drive. I think how we take it seriously, I think if you take a look at the bottom, you see the LEEDS green, platinum green mark, you see the BCA green mark. To us, that will be a very key trait in any supply chain city. If it fails to hit these standards or the equivalent, right, then we won't call it a supply chain city. We'll call it something else unless and until it meets the standards that we set for ourselves. Another thing we do from a sustainability angle, again, looking at it when I said energy, right? We actually put solar panels on the roof of our warehouses. I think to date, our facility is the largest solar farm in Singapore under one owner. And that's because of the pattern of warehouses. They tend to be wide and big. So I mentioned ecosystem earlier. Our ecosystem, we call it the Learn ecosystem, because that, again, is a key part of our DNA. We want to innovate to survive. We have to keep learning. We have to keep changing. And each tenet here, LEARN, happens to be championed by a different facet of our organization, from our operations to our training academy, to our IT arm, to the last one, and you see that, that's actually our corporate venture capitalist arm, where we work with promising startups, we incorporate them into our ecosystem, and try to take them throughout our entire network. Okay, and every ecosystem is supposed to drive something, and to us, that's innovation. I just want to take about 2 minutes of time to show you a snapshot of the key innovations that we've had and are running today. And let me know if the audio can be shared.
Yes, it can, but there's no sound. Is there enough?
There's no sound, is that correct? There's no sound, is it?
That's correct.
Oh, okay, then I guess I'll just have to, I will just verbalize then. So what we have here is actually our patented facility. We call it Fusion Areas. And a large part of it is actually automated storage and retrieval system. It's currently we have it the tallest in Asia. It's 50 meters tall. Right, and with this, we actually bring a lot of efficiency because a typical warehouse can only run maybe 3 minutes per pallet, and as you can see, we can do 450. So there's a lot of gains that we provide to our customers. Automated guided vehicles, we use this to really counter for a lot of labor shortages, as well as to upskill our workers so that they're not stuck doing low value added tasks. Things that are repetitive. So we allow the robots to take care over the repetitive tasks, whereas our people focus on things that are more complex. So this project is close to my heart. It's actually our drone technology. It's fully autonomous. We've spent about the past 3 to 4 years working on it. We've gotten to a stage where we are applying for a patent for what we call autonomous inventory management. And this gives us tremendous time savings because we can do the same job in 15 minutes where it would take 2 people about 8 hours to accomplish. So time savings. And our latest project is a move into what we call autonomous mobile robots. This, as you can see, or those that are more savvy know, this is the iconic technology for e-commerce and e-commerce automation. And we wouldn't be able to do what we do today in e-commerce without this automation. So, thanks for that. Apologies for the sound. I couldn't seem to get that to work. But so what we have here is just a snapshot of our multiple innovations. As you can see, we have the automated guided vehicles, our automated storage retrieval system, our drones, and our AMR, autonomous mobile robotics. And sorry, I should put this aside. Now, the reason why I'm sharing this is it's what is the bedrock of our ecosystem, and we believe to have meaningful innovation, you have to have a very dynamic working environment to create problems, to create solutions, and to create a place where people can share ideas. And we believe that with Supply Chain City, that's what we can do, and that allows us to create all these real-life innovations that provide real value. Just from a capability perspective, I think our Fusionaries facility, which is our warehouse of the future, it actually won us an award in 2019 for the Supply Chain of the Year. And another award we won in 2019 was actually an award from our number one customer, we call Dell Computers. We got the Best Partner in the Crisis award, and that was in recognition of our efforts during the US-China trade war saga. And again, this goes into our focus of end-to-end, because we didn't just stop at warehousing and logistics. We look at BCP, we look at continuity, we look at even strategic stockpiling together with our customer, and that allows us them to maintain their operations, even though the trade war created so much uncertainty. So that's where we are, and now I'm going to go into what are the actual solutions that we've been running, and what are the actual solutions that we have moved on to really embody this end-to-end thinking. Now, I think everything comes from a base, a core foundation, and our award-winning solutions, there are 3. These form the basis for however we run. And we call them intribution, and retrologistics. Now, bear in mind that these trademarks were come up with, invented in late 80s, early 90s. So that is how early on that we really took this end-to-end approach and thinking. So explain what they are. Intribution really is focusing on supporting manufacturing, right? And this is the solution that allowed us to really work and power the vendor managed inventory methodology, because our system would basically be able to track and keep note of whoever has the correct number of whatever this stock belongs to, when these parts need to be consumed. We even can trigger the financial transactions between our customer and the supplier at the correct time, such that you can have a vendor managed inventory model. The alternative would be that you have to do all this by paper, and that's not something that would work, because the manufacturing more so quickly. And the next one we have is the intrabution. This is a fulfillment engine designed on moving finished products into the market. And that's where we design a lot of our forecasts, a lot of our visibility towers, a lot of our control towers, and optimization engines. The last one is on retrologistics, and this is basically a fancy way of saying return logistics. We decided to brand it as retrologistics, and this is important if you're serving electronics customers, because electronics customers, they look at warranty, they look at returns, they look at damage. Right? And our retrologistics system allows us to track and keep note of whatever product has gone into the market. We know what supplier has supplied the parts to it. We are tracking the warranty. We're tracking whether this is authentic part or not. And these three solutions put together literally cover the end-to-end of a electronics manufacturing, electronics brand supply chain. Because we cover from the manufacturing portion, we cover from the fulfillment portion, we even cover the returns. And bear in mind that this was in the 90s, and I think that is really what allowed us to shape our thinking into covering end-to-end. And it's really, I think we're ahead of our time to not throw our own horn, but it was that need to be ahead, to stay ahead, and to really find a way to serve our customers broadly in as many areas as possible, which allowed us to create this end-to-end solution. So whatever name you call it, at least whatever names that we come up with, whatever innovations you come up with, to us, we always boil it down to intribution, and retrologistics, and everything else sits on top of that. And with that as our focus, I think we have never really gone off on the wrong end and not looked at it as an end-to-end supply chain. To us, it's always these three areas. We look at it end-to-end, cover everything. Right? But that is from, I guess, a traditional 3PL kind of aspect. We're looking at it from a business-to-business perspective. What about B2C? I think we can't run away from B2C, and thankfully we chose not to. In fact, from about 2015, together with our customers, I think we were always sitting down and figuring out what are we supposed to do when B2C takes over. And together with our customers, we find out their problems, we find out their issues, we find out their worries, and we try to innovate and come up with our own answers to these problems. And what we came up with is an initiative we call O2O Retail Transformation. We are using this for a number of our key customers, Dell Computers being one of them. Recently, we're also using this with Puma, the fashion brand, to really integrate their B2B and B2C into one supply chain, which we call. If you look on the right, there's a number of automation over there. If you notice that YCH, we like our robots, we like our computer, we like our innovations, we like our tech, and we're never shy away from investing because we're looking at it holistically, and we're thinking that if you're going into B2C, it's a very different ballgame, and you cannot use the same systems. We cannot use the same hardware to solve the problems of the future. So that forward-thinking nature, I think, is key to us. And what we've done is we partnered with the robotics company, they're called Geek Plus, and we redesigned their systems, right, to accommodate for this need for height, this need for efficiency. And what you see on the right is what we've come up with. What we've also come up with internally is a new system. Yes, I know I said intribution, retrologistics, but for the e-commerce, we have to develop something else. We call it order management system. And this slide really just shows you our map, our software flowchart as to where our YCH order management system, or OMS, sits in the grand scheme of e-commerce supply chain. So what I'm trying to get at is, at YCH, we don't really just look at what is our piece, what is the portion that we should be concerned about. We look at the entire supply chain and figure out where our portion fits in to make things better. Right? And just to give you an example for the order management system, what is actually, let's ignore the bottom, so let's look at the top half. What the order management system is doing is it's interfacing with the point of sales, it's interfacing with the in-house WMS, it's interfacing with even the various marketplaces, right, in order to coordinate and synchronize the entire flow of information that's going on. As you know, for B2C, it's all one by one instead of, let's say, 10,000 order item consolidated into one year. It's rather, it's one order, but you have 10,000 instances. One piece, 10,000 orders. So it's a different ballgame to manage entirely. And the number one issue that our customers face is they cannot deal with the speed of information. They cannot deal with the massive amounts of data that are running through from different sources that all have different look and feel to it. And what our order management system does is consolidates all that data into something that our customers can interact with, can understand, and also it distills the information to something that our people can look at logically and decide and plan and execute. And I think that this has been extremely successful for us. In fact, this was a system that we are using to power our very well-known cosmetics customer, at least in this part of the world. And what we did is with this system, we were able to double their e-commerce capacity during the 11/11 digital campaign and fulfill all those orders within 4 days. Their previous supplier had about half the orders, 8,000, but they could not fulfill even over 3 weeks. And what made a lot of the difference is the system and the innovations that we applied, such that there is focus, there is clarity, and there is no mistakes. And that is a key for in a B2C environment. And just one more aspect. So that was for our customers. And I think YCH, as we think in a more end-to-end fashion, we were even starting to think about what about the retail industry? What about the regional improvements that's going on? What about their supply chains? What can we help from an infrastructure perspective? And what we came up with is this smart city supply chain initiative. It's a hang-on from another initiative which I'll share later. But basically, this is a suite, an initiative that we want to put in that comprises of a number of our supply chain solutions that have been rejigged and improved upon to cater for what we call a smart city supply chain ecosystem. And this is where we put in logistics and supply chain thinking optimization to help to route traffic, to help to route flow of goods, even to track emissions, right? And all these sustainability metrics together. So I'll skip that slide. So when I say about infrastructure play, I think YCH we look at a number of factors, and when we look at infrastructure play, a key facet of our mindset is what we call asset-light strategy. But being a family company, we won't really take the asset-light approach where we run on long-term leases and make do and move on. We like to invest for the long term. We like to build very unique facilities that cater to our needs, to our customers' needs. And what we've graduated to is we've gone from a district park concept, which is, I guess, what you see nowadays, modern warehouses, yes, but it is what it is. Moving on from the district park to a supply chain city, ecosystem approach, where you look at continuous innovation, you look at building a habitat for innovation to thrive, and to our latest asset profile, which we call Superport. And this Superport is where we start to move into infrastructure game, because the idea of the Superport really is to alleviate congestion, whether it be at the port or in the city ecosystem, and allow us to remove that headache from the local governments. Sorry. All right, okay. So the initiative that I promised to share about, we call it SG Connect. And SG Connect, I know what you're thinking. It's not Singapore Connect. It stands for Smart Growth Connect. The idea behind this is that the ASEAN Business Advisory Council, every year, each country who's chairing the ASEAN would come up with their own legacy project. In 2018, when Singapore chaired, our chairman was actually the chairman of the Business Advisory Council for Singapore. We came up with Smart Growth Connect, a project that would allow us to implement supply chain solutions and support this urbanizing ASEAN cities. I think Indonesia, Thailand, Philippines, these countries, because there is a real desperate need for better infrastructure to better improve the supply chain flows in order to reduce congestion, to reduce the pollution, to reduce the inefficiencies that do happen. I'll skip this video because it's not audio. And what we came up with for our Smart Growth Connect initiative to have an embodiment behind this, our idea, YCH's idea was actually to design what we call a super pod. Now, the super pod in very simple and basic terms is a supply chain city acting as the nerve center to orchestrate and control, right? And you combine that with an international dry port, a modern international dry port, and you surround it, right, with good connectivity, you surround it with niche warehousing, you surround it with good location to have good connectivity, ports, seaport, airport, as well as to feed into the city. And this allows us to really look at how to optimize and better manage traffic once you have the superport in play. Because let's use the seaport for an example. When you have the seaport in, what really happens is that there's a lot of congestion because you have clear customs, you have to work out what goes where, you need to handle all those duties and stuff. What the superport tries to do is, with the connectivity to the port, you can actually designate superport as the destination. It will take away a big chunk of the traffic away from the port, right? So immediately, so there's no need to clear customs, but it will go in a secured manner to the superport, where we will check and clear the cargo with our systems, with our own customs, with the customs in there. But the good news is that it's away from the port, so you don't clog up what's happening at the seaport, right? And you move it into this area where it's ideally closer to where it needs to be, and it's also closer to where people can actually make sense of all this cargo, either to do value adding or to do other forms of checking and more intense requirements in the superport, which would not be smart to do at the actual seaport itself. I think this project has seen a lot of fruit, a lot of value. We've actually been secured two already, one in Vietnam and one in Cambodia. And with luck, we'll be able to put one superport in every ASEAN nation. I think by 2030, ideally we can have plans to put one in every country, because the savings are quite immense, both from an economic perspective as well as a sustainability perspective. So what with the superport, we're not running this all ourselves. The idea is to again build an ecosystem. We're looking at it from a larger perspective, because you're looking at shippers, freighters, you're looking at other kinds of logistics service providers, cold chain, for example, hauliers. You're also looking obviously at dry port, container depot operators. And I think what we are trying to do is put everyone together in the same facility, in the same ecosystem, and replicate what we're doing in supply chain safety on a grander scale, which is how can all these different players sit together and see each other's problems day to day, innovate, and really create good for the entire ASEAN, or let's start with the country that they're serving to start with. And I think that's how our message end-to-end mindset has begun to evolve from just serving our B2B customers to looking at their supply chain needs, to looking at their business needs, which is B2C, and now looking at their locational needs, which is the needs of the entire industry, by putting in strong infrastructure and getting our hands involved into these areas and inject a new avenue to look at, which is our supply chain. The idea is really to just achieve what we call efficiency, to achieve infinite possibilities, and to achieve a better world. I think that's our plan, and it's this mindset that is this end-to-end mindset that is empowering all of these movements in the areas that I just talked about. So I think this is my last slide. I think just to show you, we actually had the launch ceremony in 2020, 14th November. It was a hybrid launch between the Vietnamese and the Singaporean side of things. We actually got both prime ministers to attend, Prime Minister Lee Hsien Loong as well as the Vietnamese Prime Minister himself, to bless this event. And I think it's good traction, and I think it signals well for ASEAN, because it's one of the largest investments from a logistics sector standpoint into Vietnam from Singapore. And moving forward, I hope that with this we can spur other similar projects that show this ability for the ASEAN nations to really work together and produce real results. So with that, I end my presentation. I understand it's a little bit abstract, but it's an end-to-end supply chain thinking which is necessary. So if there are any questions, I'll be happy to answer them.
I want to let you off the hook so easily. So let me ask you a couple of questions here. One is actually in any system, and we talked about it today. So connectivity is a great issue. It's also a great competitive advantage, especially if it's coupled with local knowledge. So first question, what do you see as your competitive advantage? We got a lot of LSPs on the call today too. So what advice can you give them? I mean, you're one of the largest regional players, if not the global players too, coming in there. Yeah. So what advice would you give them, and how could this be applied to humanitarian logistics? So allow me to simplify it. One, so connectivity, what's competitive advantage using this? And three, how could it be used in humanitarian logistics? And the second question is a little bit more abstract here. We have actually seen a lot of e-commerce companies vertically integrate and acquire back the logistics services. We have seen you do the other way around. So I'd be interested in your strategy.
Sure. Thank you, Professor D'Souza, for always asking the hard questions. So let's start with what advice I can give to other LSPs. I think the advice really is hidden somewhere in my first couple of slides, which is adopt the innovate to survive mindset, which is never be complacent, but never give up either. Right, that's one. The second is always take that extra step. I think what we started out in YCH, we're quite fortunate to have a very forward-thinking chairman who always looked at how can he push the envelope, how can he do better. And in that, he framed our vision, which is to bring what we call the logistics superhighway. To put it very simply, the logistics superhighway is a myth, a legend that we will always chase, because you're talking about 100%, 110% efficiency. Everything is connected. Everyone speaks the same language. Everything happens at the exact same time, which you know never happens in real life. Right? But it's that goal that we have to always chase to do one better. How can we achieve more and more efficiency? How can we do this better? How can we improve? How can we connect the dots better? I think that is the advice I would give to the LSPs, which is, to sum up, take an innovate to survive mindset, because if you don't move forward, you'll be left out. And always try to do an extra step, try to do one more. Right? And I think that is what served us to date. Of course, all these innovations and such, these are all things that we did, but the mindset behind it is how can I do one better? I think that is my advice to LSPs from an innovation standpoint. From another more practical standpoint is partner. partner. Don't try to do everything yourself. Find your own niche, right? Have other people who supply a different niche, work together, right? And together try to take that same mindset of what can I do one better. Right? I think that is the second step. I would advise. Actually, in Indonesia, we actually took that very same approach. We didn't really set up our own transportation fleet and everything. We actually partnered with, I think, close to 100 local logistics service providers, right? We used their network, their trucks, and we provided them with our systems, access to our customers. We worked together to provide an end-to-end supply chain for our customer in Indonesia. So I think just to put my money where my mouth is, please partner, try not to do it yourself. Because there are people out there who are surviving, that know a lot as well, and we can also do it. I think that's my advice for the SPs. Now, how can this apply from a humanitarian aspect? I think it's the very same, which is never be, always try to find a way to innovate, always try to do one better. And we recognize that the issue with humanitarian crises is that it's fragmented, right? And it's very volatile. right? And how do we always do one better? And I understand from the last talk, some digital twin modeling would be extremely helpful, innovate. Some ideas of how to partner better, try not to cover everything by ourselves. That would stand to serve the humanitarian trust in good state as well. I think that is to answer the first question, Professor D'Souza. For the second question as to e-commerce, I think no magic behind that. As I explained earlier, we're always thinking how to do one better, and we read the TVs and recognize that e-commerce is something that if we don't get into it, then somebody will move up or down depending on how you say it, from B2C into our B2B space. Because as we study the trends, B2C orders are starting to take match, and it's even in some cases exceed the business to business volume of the industry today. And if we didn't get into that B2C space, then it will be sooner or later we will represent a smaller share of the pie. Right? So that is why we decided to move into the B2C space. But apart from a business standpoint, we actually saw a gap because a number of the B2C entities, the way they run, they are very versatile, but they don't really leverage scale the same way that we can. And that's where we saw a niche to fit into. And I think that's how we came up with our O2O retail transformation solution that I shared earlier, which comprises of that YCH OMS together with the physical automation infrastructure that we invested in. And that was the gap that we saw. That's the niche that we tried to serve, and that's how we managed to grow our B2C expertise to what it is today. And we'll continue to keep growing with things like live streaming, with things like analytics, customer rewards management, and that's probably how we are going to move on in the future.
Thank you so much, Ryan.
Thank you, Prof.
Thank you, Ryan. Thank you, Bob. We would like to request everyone to turn on your video camera. We would like to do another group photo for this afternoon session with our guest speakers this afternoon. Charles, are you ready?
Hi guys. Yeah, same thing as early this morning. Just open your camera, on your camera, and then give your biggest smile. And then for the next 1 to 2 minutes, I'll be taking photo. When I say 1, 2, 3, start. Just start. Then after that, I'll just end. Once I end, I'll tell you off. Okay, 1, 2, 3, start. Okay, thank you guys. That's all.
Thank you, everyone. Next, I would like to request all our participants to please complete this feedback